bearing that's on this side, you'd have to demolish that seal to get it out. They're pressed in, they just don't come out. So you don't have to take the bearing out of that side. We just want you to take the bearing off the rotor when it comes off. So apparently I hadn't had that written in the lab anywhere, and you would have to, if you were doing it right, you'd have to put a new seal in anyway. So we're like, you know what, don't worry about removing that one. I have a kind of bearing puller tool. It's kind of hard to operate. It works, but if you're really going to do a slick mag and rebuild it, there's a couple specialty tools, but they're a hassle, so don't take that one out. And in the manual, there's a dye pen inspection, dye penetrant for the rotor, looking for cracks. You don't have to do that as well. We're not looking for that level of work. Part of what we're doing with these mags is to get you familiar with the inside of them. There are different perspectives on mags, I'll phrase it that way, and a lot of it's going to depend on what shop you're in, where you're at. I was talking through this a little bit with Ryan, making sure I got my footing right and I'm teaching you well, and he said something to the effect of, my dad wouldn't hire somebody if they weren't competent on redoing these mags. And I was like, oh. What I had heard from other people was generally places, if you take a mag off, a slick specifically, you'll take it apart, you'll do points, you might inspect some things on it. If it's a bad coil, put a new coil in it. But a lot of times I've heard that if you wanted to go through and do the rebuild or the deeper inspection that you'd follow the manual for, well, all that you follow the manual for working on it, right? But to be able to say, hey, that was a 500 hour, 1,000 hour. There's a kit they sell to do it. It comes with new points, new seals, and the kit costs almost what the mag does. And that's part of why we get 10 free mags each year, is people pull them off for that 500 hour and they send them in and they go to inspect them. Either something's wrong or they just go, stamp them on airworthy, send them out to schools to look at. So depending on the shop you're on, you know, if you work at Ryan's dad's shop, you better be good at it. If you work at other shops, they're probably not going to do much other than adjust the timing and or diagnose problems, right? So that's kind of the level I'm trying to teach you at, to get you familiar with the insides. You've got to be able to set the timing in them. You've got to be able to understand what's going on and, you know, basically do an inspection. But I'm not pretending to have it where you guys could do overhauls of mags when you're done. So that's kind of where we're coming from it with this, with these labs. If you go to jars, I don't know if they still do it. I'm thinking of calling them. There's a little bit of on mechanical TEs. They'll just tell you what they're doing because they like to surprise you a little, right? But they used to do the box of parts. So I would assume they're going to be a little deeper in Bendix mags. Part of that is they expect you to have some experience. That's back to, they don't necessarily expect you to come right out of SMAT and be able to pass a JARS TE. Historically, you'd go work at a shop for a couple years getting experience on stuff like Bendix mags. And so there's always that, well, could I come right out of SMAT and pass one? Probably. Are you going to have to probably do a little bit of TE prep or studying? Probably as well, right? If it's a straight up TE for mechanics. All right, this image is some tools I gathered. Tiki went to measure a couple things. One is there can potentially be dents on the rotor where the impulse coupler bangs on it, and I believe what it actually is the dog legs have a certain amount that when they move, they can come in contact with the shaft. So if there's a lot of bang, 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 bang on the shaft, it can cause a dent in the shaft. And one of the inspections is you're measuring basically how deep that dent is. Well, that's a little tricky to do because if you take a standard scratch gauge, they're designed for a flat surface. And it's like, well, this isn't flat. It's possible, but it's hard to do. So I set up this little measuring box thing. This one measures in thousandths, and basically, if you're on a super smooth surface, I can slide the whole thing back and forth, and the gauge will kind of be coming up as it is coming to the top of the shaft, and then it'll hit the dent and go back down, and then come back up on the other side of the dent. So you can look and see, let's say I made it to 70 thousandths, drop back down to 64 thousandths, back up to 70 thousandths, you'd say, okay, it dropped 5 thousandths. I had a 5 thousandths dent. I was gonna kind of demo that up here with a camera and all, but it's hard to see. So on this particular one, it goes up, make sure I'm in my dent, goes back down, and then back up again. So I just did it kind of quick, and I was at about 4 thousandths of a divot that the finger rolled through. That's one way to do it. Somebody's probably got different ways that are better. Another one is I did find we have one caliper that has a point on it, which is kind of nice. So you can measure the thickness of the shaft, and then you can go to where the dent is and put the point in there, and that'll tell you the difference in the two, and you gotta do some math. Now, unfortunately, this one's got some rust on it, which makes it a little bit hard to read, so I ordered a new one. So we'll have a second one, but it won't be here till next Monday or Tuesday. So we will have 2 of these if you want to use them. I am not overly concerned on this lab. If you have a dent in the shaft, I'm not going to take it back apart and be like, you measured that at 5 thousandths and it was 7. I'm marking your grade down. Back to most of this particular lab is getting you familiar with the insides of magnetos and what's going on. When you get in Ryan's class, you'll do a lot more fine measuring of engine components and stuff. We could spend more time on that in this class, but you're going to do so much for him that I'm kind of like, yeah, we need to keep moving through what we got. So that's another way to do it. The other one for measuring is the tab. This one has a pretty good divot in the tab from the brush wearing on it, and you're allowed a certain amount of wear. The tab's got to be a certain thickness to start with, and then it's got to be at least so thick. There was one of these coils out in the box that it actually wore all the way through the tab. So that random parts box out there, it's kind of fun to poke through, and I was like, whoa, look at that. That one is not within tolerance. Wore all the way through that tab. So I'll pass this around. This would be another one that with a normal caliper, like the caliper's too big to fit in the divot. So how in the world am I going to measure that divot? So a caliper that has a point on it, wherever I set that down, it's hiding from me. That's a good way to get in there and you can measure the divot. I only have one right now. I'll have 2 more coming. I'm going to set this whole thing kind of out on that gray table where you guys are doing ignition leads. So if you want to use it, we'll leave it there. Normally, a lot of these tools are around the back wall of the big hammer under the MFI sign out there. So anyway, I'll pass that around so you can see the dent. Hopefully that helps as you're taking apart and inspecting these for a little bit of clarity. I'm going to get this out of the way before I break something. Oh. Okay. Last one was they have you measure the stop pin, and there's a couple things you're looking at. That impulse coupler comes around and hits it every time it engages, right? So if you read through it, my memory serves me correct, one of the things they have you measure is basically how wide the deformation is, where that thing hits every time. It can only get to be a certain width. Imagine if it keeps hitting it and hitting it and hitting it, it'll be as wide as the pin eventually. We're not going to let it get that wide, right? The one that people struggle with is there's a measurement for how far out that stop pin sticks from the magneto. So I took a picture of this one. 6361 is our model number. In the back of the manual, there's appendixes with all these images. And there's about 8 of them because the flanges are made a little bit different on everybody's magneto, where the flange is. So you got to find the one that has the correct number for you, 6361. So I go, okay, I'm this image. So on this particular mag, they're saying A is from the farthest out aluminum part of the flange to the farthest out part of the stop pin. So on this one here, that would be, well, I'll just color it, that surface to that whole surface, right? If it's a different mag, they will change sometimes where that A gets measured to. If you start switching images, they might move it to the actual flange where the gasket is, or they might move it to the back side of that flange back there. So you do have to find your specific model number in the image box and make sure you're looking at, hey, where is A? I don't completely understand what they're concerned with this, because you're like, what, how is that gonna wear? That's like how far it's sticking out. Doing research on that one last year, trying to figure it out, it sounds like it's got as much to do with if you over torque the mag or you have a connection issue, if these flanges get bent, or they use the word war, but basically they're talking something went wonky on it, because there's no reason any of that should change. Like, we're not wearing down the aluminum, we're not wearing down the length of that stop pin. So it's got something to do with if you're torquing it on incorrectly, or something gets bent during assembly. So kind of a weird thing they have you check, but I wanted to highlight that as you're measuring stuff. Okay. You're such good listeners. Check. All right, up to today's slideshow. And before we launch totally into it, I want to review what I'm going to call the chain of events for our magnetos. We use the word flux twice. We use the word current twice when we're talking about how magnetos work. And hopefully we're at the point where for most of you it's starting to spark, starting to click. You're starting to get it. But for some of you, I know we're still struggling with it. So I like to say a magneto is a chain of events, in that every link of the chain has to happen in order for the magneto to fire. And some of our chain links sound similar. So the first step is we spin the rotor, right? We're going to spin the rotor, and that creates a changing flux. And you could say field, but really it's changing flux going through that bar or going through the center of the coil. Everybody with me so far? Yep. Easy enough. Okay. The next chain is that changing flux causes an amp draw in the primary winding. A changing flux going through a primary winding coil. So that changing flux causes a amperage in primary winding. Everybody good with me so far? Okay. That amperage in the primary winding, I'm going to see if I've got a blue to keep my stuff going, causes a flux field. Right? Wait, whoa. So that's my second time we're talking about a flux field, but it's not the same flux field. This flux field is what's building with amperage from our primary winding, and then collapsing, and then building, and then collapsing. Now, so far, even if I have my key in the off position, so even if I have my magneto grounded, am I still going to do all of these? Yup, we're still going to be doing all these. I'm still going to have a magnet that's rotating when, well, okay. If the engine's spinning in the off position, so if I'm flying through the air and the prop's just going around and around and around. But we're going to die soon because I've got the mags turned off. Or maybe we're going to gently glide down. Anyway, I still have a rotor spinning. I still have amperage going through my primary. I still have a flux field building and collapsing around my primary winding. Now, it's not collapsing very fast, and very fast is a relative term. I mean, it's probably doing it 160 times a second. But in the world of electricity, I guess that's not very fast. That's not fast enough to do what we're gonna say is the magic of the magneto. The magic of the magneto below the dotted line. So, when we want to get a spark for this thing, this building and collapsing of that flux field, we say, you know what? I want to make that flux field collapse even faster. And I say, okay, I'm going to, with that flux field, I'm going to open the points. And I'm going to open those points when the amperage is the highest, right? So open the points, and I'll just say when highest amperage. Now, when I open the points, that causes a collapse of flux field around the secondary coil. So notice we said flux 3 times already, and that's partially why if like you don't have this nailed down, you're like, what, flux field, when, how? But open the points, that causes the collapse of the flux field around the secondary coil. Now having that collapsing flux field around the secondary coil induces an amp draw. And you could say it induces a voltage, you could say it induces an amp draw, you can say whatever you want. That's what causes the spark. So we'd say spark happens with that collapsing. So, chain of events, 1, 2, 3, 4, 5, 6 chains long to get where the spark is at. So, hopefully kind of seeing that, yeah, it's a chain of stuff that's happening. We're not just doing one thing, helps cement it in. Making sense for everybody?
Do you want anything about the very situation?
I left that out because you could say we could open the points when it's at the highest amp draw, when distributor is pointed at a spark plug. So there's a lot of timing that we got to make work that I left blank. So yeah, we open it when it's at its highest amperage. We also open it, or we time the distributors that when it opens, we're pointed at a spark plug. The other timing one would be, we could ask questions about when is the amperage the highest in the primary? And we go, well, just after neutral. So there's a lot of timing that's going on, but it doesn't necessarily change their chain, it's just when the things happen.
Wouldn't the second flux field be the same as the first flux field?
It's a weird overlap. So you do have a coil, and you've got your fingers going through the coil. Like if you're using the hand rules, they're same or similar, but
So you're saying that when it comes in, when the rotor changes the flux field, it creates the amperage, and then as that amperage comes, the flux field builds.
so
Or is it just the same?
yes, correct. As we add amperage, that's the amperage itself causes a flux field.
So it's a little bit delayed from the first one.
Yeah, I'd be careful to say delay. You want to picture that it's 2 different flux things going on, because the first one, we'd almost say, is it a flux field even? It's going through the iron. It's going through the low reluctance iron inside that coil. The one that collapses is more like a big drawn out.
That makes sense.
And you're like, well, technically, Case, those are. I'm like, not really, because we have a magnetic circuit that's pretty much contained in the iron. That's the one that the rotor's doing. The collapsing field is not contained in the iron. The whole point of it is it grew out from the coil, and then when it collapses through the coil, that's where we get the amperage. So it is, yeah, it is a different emanating from the coil and collapsing back onto it.
So, when it collapses, the flux field cuts the winding, the secondary winding.
Yeah, it also cuts the primary, but if I was gonna draw, here's the coil with all your wires wrapped around there, right?
Yep.
The initial flux field is because we got a magnet in here. Oops, got that wrong. And that magnet, when it's at, I got reluctance stuck in my head. Full register, it's register, not reluctance. When it's at full register, the lines of flux are going through that iron, because iron says, I like these lines of flux. And it gets contained in that iron, because there's a path for it to go from north to south. So it's just going through that loop. So red, you could say, is flux field number 1. Now, once we do that, we're gonna induce that amperage in the wire. That flux field is gonna be having things that go out like that when it builds. And then when we cut the amperage off, basically these lines of flux are gonna go wah and collapse down into there. So they might share part of it going through the iron, but the rotor magnet is pretty much always contained in the iron, where the one that actually causes the spark is this emanating from the coils, collapsing across the coils, emanating from the coils, collapsing across. Because there's no iron to connect like if that one. So that's the, yeah, I think the best way to explain it and understand it.
I guess I don't understand why when you collapse the primary, how does that induce an amperage secondary? Like
So our primary and secondary are just wired stacked on top of each other. So they're in the, you could say it's coaxial, they're in the same plane. So if I built a flux field, let's say I'm standing next to you, and we built a flux field around us, and then it collapses, even though you were the one causing it to build and collapse, I'm still gonna experience it. If you eat beans today, and you build a force field, and then the force field goes away, I still get to experience it. Right? So, now you're only, I'll play on that a little bit more, I'll play on that more. So, if your nose doesn't work very well, you might not mind so much. But if I'm super sensitive to smells, and I'm gonna be like, I might get really loud. So in the same way, our primary doesn't have as many windings, so it builds it, it collapses it, but the secondary has 100 times as many windings in there, so that collapsing field that collapses really fast when we open the points across it, it's more sensitive to that collapsing field, and the voltage spike coming out of the secondary is crazy high, because it's so sensitive to the collapsing field. It's a sensitive little guy.
So then does the resistance have something to do with that? Because yesterday in the lab, I was doing some things, it talks about one of them has crazy high resistance.
Yeah, so the secondary is 100 times longer wire. So the resistance is gonna be way higher and 100 times longer wire, right? So,
And it has to go that way to get to here. Yeah, because you can't.
well, the spark doesn't go through the points. So only the primary goes through the points, the secondary doesn't go through the points. Or the
Right.
spark, if you will.
Well, I'm saying it has to go through the way higher ohms, because it can't go through the points. That's the only way for the amperage to go.
Yeah, you're kind of thinking of it, the main thing you want to be thinking is we build and collapse a flux field with the primary, and the quick collapse, we harvest with the secondary. So if you think of it that way, I harvest the collapse with the secondary, that's the way to think of the difference of the two. Is I harvest the collapse with the secondary coil.
It's the same transformer.
Yeah, I don't like going too far with a transformer, because a transformer makes it sound like I've got some voltage on the primary, but I can get more if I send it through a transformer. It is true, it's better to think of a magneto like it's more sensitive on the secondary with all the windings. So when you have a sudden collapse, it's like, way more sensitive. So yes, it's like a transformer, but slight differences.
So the
through the secondary or the primary?
Secondary.
Yeah, you can't, I don't know if you can measure it with an ammeter. It's super high voltage,
Yeah.
but it just happens once.
Yeah.
So like, if you wanna say amps, you'd have to measure how many electrons jumped, and it's not that many, cause it only happens once. Where normally with electricity, like we're measuring it, cause it's coulombs per second, right? Well, it only happens once, so it's just one batch of them go flying down the wire, where normal electricity, a second's a really long time.
Sure.
And if you got a lot of electrons going through that wire for a whole second, now we can measure amperage. Yeah, you're not, it's very low amperage if you wanna measure. We're not even gonna talk of it like amperage, technically.
Yeah.
It'd be interesting to know, but yeah. Alright,
The collapsing field off the primary, is that being induced on a secondary coil, or is that not?
so the collapsing field of the primary induces a voltage or amperage in the secondary, is how you would phrase that. Collapsing field induces a voltage on the secondary, yep. Okay, alright. We are moving the right direction. Hopefully we're getting there. And, think of it like that chain, I don't know what is going on. Let's see, erase. Think of it like that chain of events is we're a chain 6 events long to get the spark out. So if you try to say when the point's open, the electricity goes through or something like that, you might in a purely timing way be correct. When the point's open, we get a spark, but you might be talking about part of the chain that's halfway up when we're asking questions about down here. So which link of the chain are you asking questions about right now is a good thing to be thinking about if you're thinking about it and somebody's asking you questions. Hey, which one of these links are we specifically talking about right now? And that's the same with the components. Which one of these links does this specific component deal with? All right.
Wait, can I have a question?
Yeah, I'm looking at the time. Tell you what, we'll take a question, then we'll take a break, and then we'll get into lecture today.
How did the contact cord open? Is that?
We'll cover that in the lecture. There's a little lifter that's on the shaft that's spinning, and when that lifter hits the contact point lever, it opens the contact points.
Shaft meaning the main rotor?
Yep. Let's take a break. We'll make it a shortish one, I think. So let's come back at 47.
You know that basic knowledge turn that day, right? Yeah. So I sent it to you. When I was 30 seconds. Yeah. Not just people, but actually like think about things you. I wrote down this.
Hey. Yeah, I found somebody's homework. James. Oh, good thing it was graded already.
I click on the answers.
I don't want you to be bugged out. I want you to be happy. Is bugged out good or bad? My interpretation is that it's incredibly good.
We did some English class, went to college class. It was I love these advertisements. They don't do them anymore.
Yeah.
Advertisements for vehicles and all the sayings and stuff.
Vehicle, like, advertisements now are just so,
Yeah, not like that.
any type of commercial, it's like immediately, it's always the same thing.
I did one on Porsche.
Oh, it's a Buick. Dun, 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 dun.
Get out of here. Volkswagen's big thing was you could fit the whole family and still get 40 miles per gallon, and it would barely run.
And they delivered on all their promises.
Yeah, like, well, I mean, Volkswagen was a drug company during right around that year. What promise?
No kidding. Are you a Volkswagen guy?
Oh yeah, my first car was a Beetle.
Really?
I have a Beetle now, but I don't keep it. I like someday I'll redo one. Sure. Got a little more knowledge than I did when I was 16, a lot more.
As it, maybe as like a retired.
I don't know, I just like, I have a, I don't know, I like, that's what that sandblaster, I really like actually cleaning up stuff and not painting over it.
Oh, yep.
You know, start sandblasting, you're like, wow,
That's crazy how quick it can be.
it's amazing. I wish that thing would work better. I gotta figure out, I dedicated myself to doing that long time. It's taking us. And then.
We're using the big one, using the big sandblaster.
Yeah, it's not feeding consistently. So the other sandblaster works great, because it just keeps feeding. And I'm just like, the other one's like.
Kate, I think I told you again.
Yeah, and it's like.
Okay, you too?
It looks really good when you get it. I know
Shane,
I know how they
talk
should.
to him.
Sure. I don't know if maybe put a standpipe in there, because the hose kind of
Okay.
is free to do
What,
whatever.
8:30 for
But
everybody?
eventually it sits on the top.
Alright, 3 of us anyways. You'll,
If you get a
likely
standpipe
miss
down in there like zip
our
tie.
internal timing of appendix mag,
Maybe.
which
I just haven't messed with it lately.
I'm
because
probably
I
not
figured
gonna try to
today.
attempt in front of
It's
you.
not a priority.
I'm gonna basically explain it, so
Yeah,
just make
you're
sure
about to kill it.
that either A, watching the video, B, when Ian gets back, or C, when he
I'm
gets
worried
that
about
out,
really hopes.
make sure you realize
You
you're
can
just
get
an
33
extra
wrong,
little bit
but
of time
it's not
to
what I
say,
want to do.
I have no
No,
idea what's going on
that's
here.
definitely not what you want to do.
Kind of help me with that.
But
Okay.
I did
Otherwise,
do 600
watching
and got
some
100
videos
rolls,
online.
so that was.
They're a little,
I hope I got better since then.
Oh, absolutely. It's one of those things, from what I gather, there's the how we do it, then there's how the manual's written.
Okay, I'm really
How
glad
you
it's last.
do it will be how the manual's written,
Yeah, I guess.
but not necessarily
Just kinda messing
in the
with
same
more price.
progression, so it can really like.
Learn a little bit.
Okay.
Are you
It'd
coming
be
out?
like when you drive a car, they'll say, walk
I'll probably
around,
be there
check
15,
the
20 minutes.
tires, check your
2
oil,
hours.
right? But when I go driving, I jump in the morning, I
Oh,
drive to the gas
it only
station,
takes me like.
then I fill it up with gas, then I check the
Socially sit
oil,
over
then I check my tires.
for an hour.
So I'm doing everything the manual said, it's just in the wrong
Yeah.
order. So
I'm gonna leave the house at 6, which
if
will
I have
put
a
me
flat
there.
tire, I'm still gonna catch it.
15,
It's just,
Sure.
which
Plenty
is
of
the right
drive.
time. Yeah, it could be even longer, couldn't it?
Right.
Uh,
Hey Marcy, did you work at this IHOP?
No,
No, you're just vested interest in the industry?
no, I've just been in the service industry since I've been like 16. So,
You appreciate what they have to put up with.
yes, yes, very much so.
That's good, that's good. They are underappreciated sometimes.
It's like the worst feeling when it's like you come into work, it's like the beginning of your shift, and then all of a sudden you get sat with like a 12 top, and it's just like, okay,
A lot of times I've noticed it's not always their fault, it's just poor management.
yeah.
Like, you go in there and you expect, reasonable service. Yeah. But they only got 2 people.
Right.
My goal is to have.
Not much you can do with that.
Yeah.
Just 2 people like that. Yeah, that would be awesome. It's like right now.
Oh, today.
I'm sure Tiki would agree.
I'm sure Tina will agree.
It just feels like we're so
Why didn't you wear a sweatshirt? Cause it's not cold enough to wear a sweatshirt. How is 38 not cold enough to wear a sweatshirt? Okay, not everybody else is wearing.
I just took mine off.
Yeah.
I think that's because I'm nervous though.
He's the teacher. He can do
You can do whatever you want.
when you're sitting, it's much colder than when you're actually.
Yeah. You can walk, pace around back and forth, blood flowing, staying warm. Speaking of blood flow, I need to do push-ups.
is that since I'm sensitive to it, I don't normally have bad breath because I know this, but all right, welcome back. We've got a lot of important stuff to cover today. Depending on who you are, will define how important is. Part of that ends up being some of the stuff that the FAA still teaches, and then some of the stuff we still teach, and even, let's say, JARS with you're going to have to rebuild a Bendix mag maybe, is slowly drifting off into obscurity because we have new magnetos, like a Surefly magneto. I was talking to Richard over at the LLC, and he said probably about 1 out of 10, I caught him not technically mathematically, he was just guessing. There's probably 1 out of 10 mags that are working on our Bendix. The other 9 out of 10 are slick. So apparently slick's got the market because, well, they are slick. And then he's saying he is seeing more and more Surefly magnetos. So I think he even mentioned he's seeing more Surefly magnetos than Bendix magnetos. So we got to figure out how to adjust for that. Part of it is the FAA and writtens and stuff is still geared more towards, Bendix and whatnot. They're slowly working in what we call E-mags, electric mags, which we will have a lecture on later, and I'll cover a bit. The main thing with E-mags that the FAA wants you to know is they generally need a power source. So if the battery goes dead, your E-mag does not work. The way to remember that is the reason we don't see a lot of airplanes with 2 E-mags is you would have to have backup power for them. So if the battery goes dead, there's got to be a backup power source. We'll cover that in a different lecture, but that's one of the big things with E-mags is they need a power source to operate. Now that's generally, there's a couple of them that I figured out how to do it, but that's the general rule.
I thought the entire purpose of having magneto was that it was an independent
I know.
electrical system.
The problem is, once we go to E-mags, they're circuit board driven, and now I can advance and retard my timing based on aircraft power settings. I get more fuel efficient. So yeah, they are less reliable, but we save a ton of money with them. So we go back to, you could say, less reliable, save a ton of money when we go to an E-mag situation.
So how much fuel are we saving? Like 0.1 gallons per
Like
hour?
$20,000 a year for Samaritan Aviation. That pays for an E-mag. So, Randall.
I got 2 questions. Are, like a car, if your battery is, everything still goes through your battery? Like if your battery.
Yeah, your car does not run if your electrical system fails in your car because there's no electrical. Now, you have an alternator which is producing power. So notice I said if your electrical system fails, not just your battery fails. So as long as your engine's running, your alternator technically continues to provide power to your car. In an airplane, maybe, maybe not. The problem with that is if you're in the air, you can't pull over to the side of the road. So you can't like restart because if the thing stops spinning, I got no power.
So we're just flying cars now.
Getting closer.
The other thing is, do manufacturers, like, do they typically run the slick or Bendix, or do you get an STC?
Used to be you'd pick. You'd order an engine and they'd ask you, do you want a slick mag or a Bendix mag?
Both
You'd
would
tell
be
them.
easy, yes.
Yeah, you'd get to pick.
Oh, if we care about like not having our engine die in the air so much, why don't we just use like diesel engines?
Diesel engines they destroy themselves on airplanes. That's a lecture for later, but diesel engines really go bang really hard at ignition, and that causes the prop to do that, and they're still trying to figure out how to have the engine not destroy itself when it does that with a prop. They're getting closer, but that's why we don't like diesel engines. The bang is a problem. There's some other minor things like fuel at altitude and restart, but the biggest thing is they have such a big bang, and when your prop is connected to the drive shaft, that's problematic. All right.
I was reading just this comment that Surefly magnetos get overhauled past 24.5 hours.
Yeah, the overhaul's way longer. Yep.
And they're about the same.
If you're on the, yeah, and they're about the same cost, yeah. We have a whole lecture on that coming up. less about e-mags, more about these mags don't need a power source. That's the intent of the question, but there was a pretty big clue right there.
So, Surefly aren't
They're e-mags.
but they still.
Electric
they
mags,
still
we
have a
call
big
them.
rotor on them.
We still call them e-mags. Alright, so basically, all those were great questions, and that's kind of what this lecture was for. So you guys are thinking kind of like me. It's a little bit of a review time. Tomorrow we're at Amway. Monday I've got some lecture with review stuff. But this is kind of, let's take everything we've learned so far and make sure we're all kind of on board-ish. And then after that, we'll take a break. And then after that, I'm going to explain roughly how to time Bendix mags internally. Go.
So, let's say like, you're taking off with an E-mag and like, you accidentally hit the master switch. You're just going to 0 RPM. Like you're impossible turn. Or-
Depends on the brand. FAA would say generally speaking, yes.
That's literally insane.
Yep. Now, because of that, they all have a battery backup. Or you have one E-mag and one regular mag. So that's why, generally speaking, yes, and then we start putting a bunch of safety devices in line. But we'll talk about that during that lecture. Okay. How many cylinder engine is this? Kurt? What?
Oh, wait, I thought it was-
Very good.
I know what you're talking about.
Jedediah, what is the switch on the top left?
That is your,
Should
it's
I
the
ask?
off switch. It allows the ground, the electricity to get to ground over there instead of having to jump.
Yeah, there we go. We don't typically call it the off switch. We would call it the mag switch or the ignition switch if you're in a car. But yeah, it's your off both left, right. So yeah, yep, very good. Okay, question before the name. That way y'all have to get it in your head first, right? That's what I gotta do. What happens if that wire breaks to that magneto switch, Jordan?
Which wire, sorry?
The one to the mag switch we were just talking about.
If you don't have a battery backup, stop.
Say what?
If you don't have a battery backup, it'll just die.
Oh, incorrect. If that wire breaks, you will not be able to ground out your magneto, which means I can't ever tell it to stop making spark. Yep, it's always on. It's the opposite of what you're thinking about.
Does that do like a runaway engine? Like you can't stop the engine?
No, because you still have a throttle, you still have mixture. When we shut engines off, we actually typically shut them off with the mixture. We starve it of fuel and the engine's like,
So you're choking it to death.
yeah. Well, technically suffocating it, not choking it.
Well, like
But-
my weed eater, I put it
Yeah.
on choke because the on and off button doesn't work. So
Yeah, choking technically is you're putting more fuel in. So when you're choking on something, it's plugging your airways. So I would say suffocating is we're stopping air from getting in. But yeah, and stopping fuel from getting in. Okay, when does this spark? Now I'll take a bunch of correct answers here. I'll take a bunch of correct and we'll just start adding some. But when does this magneto spark? We'll start with Ryden.
when does it spark? When the contact's open.
There we go. That's the number one answer. Very good. I think we should have a affirmative or non-affirmative from the audience. I realize this isn't quite as fun as Cahoodle, or whatever that other goofy game you play is. Cahoodle. So I'm thinking snap. If you think he gets it right, you all know how to snap. And if you don't think it's right, we need tap. So if it's right, you snap. And if it's not right, you tap. And we'll see how this goes. And that way I kind of see, did they know the answer or not, too? It helps me out. Okay, when else, not when else, how else could you describe when we get spark? How else could you describe when we get spark? So the number one answer is when the contact opens. That's good. But there's a couple different ways to explain it as well. Heat heist. think timing. Or think the chain of events, all those chains we had. You could say, what's happening in some of those chains? I'll take that. So when he says the clock, so this is our distributor. So it sparks when the distributor finger is pointed at one of the plugs. I like it, that's good. All right, Clayton, give me another, when does this spark?
Slightly after the neutral position.
Slightly after the neutral position. Very good. There's one more answer, Tiki. We're not going to penalize you if you can't remember it, but there's one other correct answer I know of. But see if you come up with it. If not, I'm going to put you back in.
When amp draw is the highest?
Oh, there's two more. Very nice. Well, yeah, pretty much. Because we open the contacts when the amp draw is the highest. So, like in a very technical sense, it's just after amp draw is the highest because it actually sparks when there's no amp draw. So,
That sounds like a yes, dude.
right?
You're not giving us enough time to do it.
More time?
Yeah.
Okay, more time. Okay. The other one I would take is at E gap. So E gap is when the points after open after neutral position. We call that E gap, the number of degrees after neutral, the points open. So just another term is E gap that we got in. Okay. Ooh, this one's tricky. Label the capacitor connections. Label the capacitor connections on this drawing. So I want one to be, let's say, shell, and I want one to say P lead. So Geese, you could come up and put the word P lead and put the word shell on my capacitor. Nice, nicely done, nicely done. All right. Circle the primary coil, Samgon. Ooh.
He's gone. I have a 50-50 shot. How could I possibly mess this up? Ready for a speed run? Yeah, let's see. I like this one.
Nice, so that makes the other one the secondary coil, right? So, with that said, I got a primary, I got a secondary. The drawing, when you see this with lines in between, tells us that they're wrapped around essentially the same piece of iron. That's what that's drawn. So that's how a transformer is drawn. Those lines mean, hey, they're wrapped around the same coil. So, Corbin, with what I just said, knowing that both coils are here, what type of system is this? I can give you some more clues if you want, but we're going to start there.
I'll take another clue.
You'll take another clue?
Yeah, I'll take
Does somebody want to shout out just a one word, and I don't want
like
high. Well, okay, there's your clue. I got high or low, but I still didn't give you the important word.
this might be dumb, but like a step up.
So I want to hear high and low, high or low in the answer, and tension somewhere in the answer. So is this a high or low tension system?
I'm gonna say it's a low tension
So
for the pry.
those little critters are coming for you. So the wire going to our spark plug determines if it's high or low tension. Is do we have super high voltage leaving the distributor heading out to the spark plug or not? On this one, it's after the secondary, so this is a high tension system, super high voltage headed to the spark plug. If it was a low tension system, the secondary coil would be out by the spark plug, which means I'd actually have, well, it's going to be drawn similar, but I'm going to have a little step up transformer at the spark plug that we call a coil pack. You can call them a couple different things. Yeah.
So your coil and distributor we swap positions if it was a low.
Only the secondary. We still deal with the same thing on the primary. And back to like the whole logic of, okay, is it the same flux field or not? We would still build a field around the coil, because Amtraw's in the primary. We would still collapse that field across the primary, but it's not as sensitive, that primary coil. So you would still get a voltage spike headed that direction, but it wouldn't be a high enough voltage spike to give a spark. So we'd put a little coil out by the spark plug. Where's my coils? We'd put a little coil out by the spark plug, and this is 3 different styles, that would say, hey, I'm gonna take that voltage spike that's not quite high enough, and I'm gonna ramp it up by probably about 100-fold and make it 12,000, 24,000 volts to jump across the spark plug.
That's a transformer.
That is a transformer. That is straight up transformer once we're talking coil pack.
Can you use the same transformer, like, can you put it like in between all the cylinders? 'Cause you have-
I don't think it works that way.
the spark is going in a different.
Well, let me rephrase that. If you wanted to do that, we're just gonna make it a high tension. Yeah.
Is that common at all?
Low tension?
Yeah.
So this is high tension. High tension is the most common. Low tension in aviation, not so much. I think radial engines, some it's mainly older stuff. Once we figured out how to make spark plug wires so they're insulated well, we're like, it's a lot easier to just do it this way, because now I only got one of these, and I don't have to, on a 6-cylinder engine, put 12 of these out there. 12 of those, that's like, we're getting some serious weight. So I don't wanna have to put 12 of those out, one for every spark plug.
What with your car?
Your car has gone to low tension typically. We don't care about weight in a car, so we're like,
Can you pass that little guy around the, yeah,
sure. There you go.
Hey, Chase,
Yes,
why is it called, like, low and high? Why?
high voltage, low voltage. Tension is another word for pressure. Do you feel the pressure in the air? You feel the tension in the air? So high tension is high pressure. Low tension, low pressure. All right, there's some tension on this next question. When would any of the answers given for when the spark happens? So contact points open, E-gap. What other answers did we give? Highest amp draw, which is technically, I don't like that answer anymore. Lowest amp draw? Right after the highest amp draw is
Well,
what I,
when you drew it on the board, didn't you have
yeah, I
contacts
said, well,
open
there's a,
and
yeah,
highest
you're right.
amp
The
draw?
reason I say I technically don't like it is we don't get a spark because of the amp draw, we get a spark because we eliminate the amp draw. So there's that minuscule delay. So that's why I like your answer, but technically by a 1,000th of a second or whatever, it's incorrect. You missed it by a hair. You missed it by a hair. Right? All right, Randall, this one was for you. When do the points open any of those answers on a 4-stroke engine?
Cam load with the little switch.
That's inside the magneto. I would say that's correct, but focusing on my Otto cycle, at what point in my Otto cycle, and I'll say when my engine's running, like not when I'm cranking it, at what point in my Otto cycle do I want the spark? That's really what I'm asking.
23 to 25 before top dead center.
Yeah, so before top dead center, somewhere before top, 23 to 25 is pretty common in there. Very good. All right, how about when I start the aircraft? When I'm starting the aircraft, then when do I want the spark, James? After top dead center, because we don't want to have any kickback going on. All right, you guys are doing pretty good. So far, you're going to do about 95 on the exam, is I think what I'm hearing, right? So not so bad. Assuming the spark plug shown is cylinder number 1, label for me which cylinder those other wires go to. Christian Cheddarquist gets this one. So come label for me where the this wire, and this wire, and this wire, and this wire, and this wire goes. And do I need to tell you that is a right rotating mag?
This is currently on 1, you said?
1, yes.
Hey, Keith, while he's doing that, I have a question.
Mm-hmm.
Why would you want low tension system?
Because before we figured out how to make spark plug wires that could insulate 24,000 volts without breaking down, they said, how do we keep these spark plug wires from going bad? I said, well, let's send it lower voltage. That's pretty much the only reason.
So then would you have to make the gap closer on spark?
Nope, you would install a coil pack like we're passing around right next to the spark plug.
So you step it up just right.
Right before the spark plug, yep. That way, instead of a 4-foot long wire in a bundle, you've got either a little 3-inch wire or sometimes no wire. Sometimes that coil pack is like on the spark plug.
So it's just so you can protect the rest of the
Yep.
wires.
Yep. All right, 1, 6, 3, 2, 5, 4. Very good, very good. You got the numbers off here. It should be stamped on the engine somewhere. It's always going to be in the maintenance manual, TCDS, stuff like that too. But stamped on the engine is the #1 answer if we were playing Family Feud. And is that stamped or cast? Cast on the engine maybe would be a better way to phrase it. So if you were playing Family Feud, cast on the engine is the #1 answer.
And for you know, it's right rotating because of like the data plate, or where would you find that?
On the magneto itself. Yeah, it won't say on the data tag. It's going to say on the magneto.
Yeah, the plate.
Yep, the plate on the magneto, yep. And remember, right rotating means clockwise, both here, and if you spin it around, here, because there's a gear that reverses it. So it doesn't matter which side you look at, if it's right rotating, you're going right, you're going clockwise. Okay.
Case, how do you know which cylinder is which number?
The cap will always be stamped with a #1, or cast might be a better word. So if you look at your wiring harnesses, there'll be a #1.
No,
They-
I meant like the cylinders itself. Is that a question?
Carter, on a Lycoming engine, which cylinder is cylinder #1? The one that fires first? I'm gonna go with no, just because we don't know when I shut the engine off and it goes, we don't know what one it's gonna start on.
Then would it be the,
Oh,
I can't remember.
he's thinking about it.
I don't know.
Wait, we're gonna try this out, because this helps me know what the exam's gonna be. Caleb, Lycoming engines, which cylinder is cylinder #1?
One of the two closest to the prop power.
So he said one of the 2 closest to the prop. There is always one cylinder that's closest to the prop. So on this engine, this one's a bad example because it's cut off. We'll see. Let me see if I got a drawing of a cylinder, an engine. I don't. Okay, I'll draw. On our engines, because of the way the crankshaft works, we're always going to have a cylinder, and even though they're the front 2, one is always a little bit behind it. So you always have one that's closest to the prop. The other front one is slightly behind it. So on a Lycoming, it will always be closest to the prop. Now, I might have just drawn that backwards. I can't remember if the left one or right one. Front right.
Hey, you can say the bottom.
You're looking at the bottom of the engine now. You're looking at the bottom of the engine now. Some people have memorized that on a Lycoming, the right bank is the odd numbers and the left bank is the even numbers, because they have memorized which side's closest to the prop. I should, but I don't.
On both, the co-pilot's always on.
On what?
On Continental and Lycoming, the co-pilot's always on.
On both of them. See, I didn't have it memorized. Randall, he's sharper than me. He knows that the co-pilot's always odd. I like that. Yeah, that's why we won't let him be the pilot. They're a little odd. Yeah?
So for cars, we have like variable spark that increases as.
You gotta have an E-mag for that.
That was my one.
Yep. ask for us to pass them around.
Yeah, I was referring to when you held up something and said this is a coolback.
Yeah, you still got one or two coming. You still got one or two coming behind.
And they're all cool.
They're all coil packs.
Okay.
Is a coil pack just a transformer?
Mm-hmm. Sure is.
Another word for it.
Yeah, it's specifically a transformer that's gonna send spark to a spark plug. So it's a specific kind of transformer. Kinda like we're both mankind, but I'm a man and you're not. So a coil pack is a specific kind of transformer. Okay, I gotta figure out what the next question is. Okay. We already did that one. Oh, this gets trickier. Label my green wire and white wire on the drawing. Ooh. Matthew, Blazer.
They're all black.
Well, I got right here. I got a green wire and I got a white wire. Which wires are those on my drawing?
I think the green wire is the one that the P-lead and the bipartisan one is.
So, give me you know that game where you got a claw? You gotta say up, down, left, or right.
Ain't nobody.
The straight line is.
That's not up, down, left, or right. Have you ever played where you gotta grab the thing out and it's like, yeah, up, down, left, or right?
On the capacitor.
No, up, down, left, or right. I'm not budging. It's either that or you gotta come draw it. So this is up, that's left, that's right.
Which one's down?
That's down.
Go about 300 degrees. You're a pilot.
There's the compass, north is up, south is down 300 degrees. It's like,
All right. Circle my green wire. Okay. Oh, what do you guys think? Yeah. So you circled the ones on the capacitor, and I can't even see my capacitor. My capacitor done got removed when I took the shell off my magneto, right? So there is no capacitor in this image. So those two wires are not there. So, Shane, you want to do it? Come on up. Yeah, you want to play up, down, right, left? Okay.
Alright, up. Oh, you missed your turn. Oh, go down. Left. Circle that wire.
That there?
Yes, sir.
Okay.
Move your hand so I can see.
And that's green?
Yep,
Okay.
that's,
I don't have a white, so we'll make the white one blue.
go up. Stop, left, that's white.
Okay. Let's double check ourselves. One of them is basically going to be connected to the P lead heading out. He's saying that's the green one. Yeah, because the capacitor gets hooked up to this terminal here, so electrically that's the same point. So good job. And the white one is, oh, they have a bad drawing here, grounded. That's probably supposed to go through like that, right? Bad drawing. All right, good job, Joe. Very good. Okay. Just for the fun of it, whose name do I got? That's Shane. Oh, I need you to, we'll play the same game, up, down, left, or right. Where is that tab in the image? Israel Welch. Ooh.
Whoa.
Well, the claw starts in the corner.
Stop. Go up. Stop. No, go down. A little to the left.
Answers? That's a little tricky. I would tend to.
There's no wire.
So,
Technically, there's no wire.
I mean, the coil absolutely correct, but I was specifically asking the tab itself. This tab right here, that tab is what
It's
your
not on
brush
this.
in your distributor
It's not on the distributor.
rubs on. It is too. What they do, this distributor, in real life, this distributor sits right on top of there, and then that tab would be right there, right? So if you wanted to say, where's the tab in the image? I see I see where you're, yeah, okay. I see your logic. That would be one of those ones where with a little explanation after exam, you might be able to get that point back, right? But basically the tab is what's feeding the power to our distributor here. So I would have put it there. That's probably the best answer. But I see what you're saying. It's the power coming out of the coil, and that's why you answered it that way.
Is this going to be a question on the exam?
It wasn't.
Are we gonna have to tell you to move the
That, that would be a great, great question, and all it'd be is a mouse click. Click here, but no.
Because Israel, the way I'm looking at it, he is correct. I mean, you're both correct. It's tomatoes.
I would tend to agree. If he had circled this one, or this one, or this one, or this one, or that one, or this one, then he'd be wrong. So we're, yeah. That's why I'd say if he had got an answer like that on the exam, and I was like, no, and I'm like, well, okay, I see what you're saying now.
So then if you were asked to label where the brush is, where would you,
The what?
the little brush?
Oh, at first he said brushes, and it kind of made my ears go, ah. There's only one brush. Brush.
So where would you circle that? Wouldn't it be on the distributor?
If see, I like that question, Randall. If I said, where is the brush, you would absolutely have to go here, right? But wiring diagrams don't show where things are in necessarily the physical world, so yeah. You're all right. And he is right. Have you guys seen Fiddler on the Roof? And he is right. He is right, and he is right. How can they both be right? You are right as well. All right, where am I? We got rapid fire through these ones. I don't want to take too much time. How many poles on this magnet rotor, Amanda? Four is the correct answer. David White, oops, sorry. Is this in neutral or full register? He gone? Mike, neutral or full register as shown? Neutral is correct. Oops, don't look at the name. What would we call the positioning here, Marcy, as drawn? There's a couple answers I could take. Other than neutral or full register, could you come up with a, oh, that is showing the magneto. Finish the sentence for me.
That's where we would open our contact stub.
Correct, and here it shows it open. We'll take that. Yeah. Open the, what is that? What does opening the contact do? Just so you know.
Collapses the field,
Which does what?
which reduces the amp draw in the secondary winding.
We'll just keep going with this. This is fun. Which does what?
Makes the spark.
Yeah, we did it. She got it all right. Very nice. Very nice. Okay, cool. And that's the hard part of this class, right? It's that whole progression chain of events to make sure you have the whole thing. Okay, what's the blue circle on this picture, Ava?
Can I say distributors?
Yes, you can say
Okay.
distributor. Thank you. It's a part in the magneto, the distributor. This gets trickier. How many times does the distributor go around for each rotation of the engine, Nathan Swift? No. Randall. 1/2, yes. So the engine is gonna rotate twice to make it all the way around and fire every plug. So that means that if the engine only goes around once, I'm only going halfway around. Maybe I shouldn't have drawn all three, but yeah. So, assuming the engine is running at 1,000 RPM. RPM. Engine. Okay, assuming the engine is running at 1,000 RPM, and here's why I would get scratch paper for the exam if I was you. How many RPM would the distributor be running at? Thomas?
Got me. Okay. You guys question.
My engine's running at 1,000 RPM on the tachometer. The pilot's watching the tachometer, and that needle is stuck on 1,000.
Yep.
How fast is that distributor running?
It's gotta run, for every half, the distributor runs half. If the engine goes over once, it's only running half of the distributor, so the distributor has to go twice as fast, right?
Oh boy, now I just got myself confused. Hold on. Did I type this backwards?
Absolutely.
So, my distributor runs.
You said 1/2 times the engine runs 1 revolution. It takes 2 revolutions
Yeah,
for the distributor.
sorry, my brain just went like, So the engine is gonna run 2 rotations for every time the distributor does 1 rotation.
I'm thinking of this wrong.
So that means the engine's running twice as fast as the distributor.
Okay.
Yeah, sorry. All right, so with that said, now that we have this written out, what's my distributor running at?
Distributor's 1 rotation for the engine is 2 rotations, so, like Zach said, 5.
500 RPM. And as you can see,
I was thinking of it backwards.
I got myself confused there, and I have the notes typed right here. I know the answer, right? So, was it moving slowly over time or something? I would, if we give you a scenario, or if you're thinking through it, oh, you guys are moving too. I would write this down, and I would tend to start with engine RPM, say distributor RPM, because then the next question is going to be, with the image given, how many RPM is the rotor on my magneto running? You just want to answer it?
No, I want a question.
Yes, Zach?
I wanna ask you a question.
Christian Reed Smith, I want to know how fast the rotor is going. And then I'm going to take Zach, so you just ignore our conversation. The rest of you can ignore it too while you figure it out to make sure Reed is right or wrong. Mr. Wood.
If you have a 6-cylinder engine, are you running once for 3 times?
On the distributor,
Yeah.
the distributor has to go 1 time around to fire every cylinder once.
On a 6-cylinder?
Correct.
Every cycle the prop is going around, all cylinders are fired?
No. The engine, because it's an auto cycle, 4-stroke, has to go around twice to get all the cylinders to fire. The distributor cap, the distributor itself, goes around once to get every
So
cylinder to
that's
fire.
the set ratio for what you need for cylinders.
Yeah, yeah. I'm a little hesitant, we'll talk about radials later, they're a little, they mess with you, but, so save radials on that, but for these type of mags, yeah. All right, did you come up with an answer? No, no. All right, so we'll take one more name and then we'll help them out. Tiki? This one, if you go to a Mexican restaurant, this question gets easier. Because Sherlock Holmes likes to go to Mexican restaurants. It's where he gets his best best case ideas. So you can do it mathematically, or you can kind of like just look at this and use some deduction and be like, all right.
Is it 500?
500, she says. I'm gonna write down for an answer and then I'm gonna check it. How did you get to 500?
Doesn't the rotor spin what makes the distributor build? So would that be
That statement is correct, except we have gears in them. So
it's
depending on the mag, we might change the ratio between the rotor and the distributor. So if that's the reasoning, I wouldn't hold on to that too tight, because if I start switching my magneto to a 2-pole, and I start switching my distributor to a 6-cylinder, those ratios are gonna change. Job?
Yeah, take a stab at it.
Yeah.
2,000.
Job's gonna say 2,000. I'm not saying Tiki was wrong, I'm just saying her logic was wrong. So, what's your logic?
Yeah, so our rotor, oh boy, that's great.
Yeah, Job's not right. Alright, here's when I look at this, kind of the easy one, is every time this goes around, I get a spark on every cylinder, right? And we already said my rotor is going 500 RPM. I didn't write next to it, rotor. Okay, now, distributor, I'm sorry, distributor. There, we already said that, right? Distributor's going 500. Well, I got 4 poles. Every time, technically it's a neutral goes by, but whether you want to call it a neutral or a pole, if you were to pick a point in space and say every time the pole goes by there, we're going to get a spark, right? It sparks just after neutral. So with this rotor, I have 4 available neutral positions. So if I got 4 available neutral positions, that's the same number as over here. I'm going to be running the same RPM. So that would be the easiest logic to do it. If you want to be complicated and do a bunch of math, you can say, okay, so my engine's running 1,000 RPM. That means I need how many sparks per minute? That's kind of tricky, isn't it? Because it's 4 cylinders, but they only spark every other RPM. So you would go to 4,000, but they only spark every other. So I need 2,000 sparks per minute out of this magneto, right? 2,000 sparks per minute. So I need 2,000 sparks per minute. And I get 4 sparks for every rotation of my rotor. So I need 2,000 sparks, I get 4 of them for every rotation, so that's gonna give me a 500 RPM. So you can come to that answer a bunch of different ways, but you've gotta come to the right answer. So if we switch this up and change our drawing, and do the whole thing again, and say, okay, we're gonna get rid of him, we're gonna get rid of him. I now have, maybe I gotta draw those out. I now have a 2-pole magneto, which is what most of your slick magnetos are, right? And we're gonna add ourselves 2 more cylinders. I realize they're not spaced correctly, but just live with me. So we have a 6-cylinder engine. Cylinder? We'll count. And we'll say this guy's running at pattern RPM at 2,000 RPM on the engine. Alright, so that's what we know so far. 2-pole, 6-cylinder, 2,000 RPM on the engine. Okay? How many, and I would approach it a similar way. I would say, kind of like electrical, let's just figure them all out, but how many RPM is my rotor going to be going? Zach?
Rotor or distributor?
Oh, sorry, distributor. Thank you. Wow, you even knew what I was thinking.
1,000.
1,000, because it goes half the speed. So 1,000 RPM distributor, and I'm going to ask that rotor question. So how fast is my rotor going to have to go? I would say, if everybody comes up with a number, but we'll pick on Grant. So So, let them work on it. The rest of y'all can work on it. I'm gonna blank the screen a minute. You still have what you need. Yeah, the rest of those will work. I didn't come up with my number yet. Let's see here. All right, I got my number.
1,500?
See, my number's off.
No, that.
Oh, you're right, you might, sorry. I had the wrong number. After you said that, I'm like, that sounds about right. He's gonna say 1,500. I gotta do my math again. Yeah, that's where I went wrong. Okay, I got my number again. I still don't agree with him, but we'll see. We'll go through the logic and see how we get there. How many of y'all agree with Grant?
Don't at this point.
Uh-oh. How many of you have a different number? Oh, Matthew, I saw your hand. What number did you come up with?
Guess I shouldn't have raised my hand. I'm gonna say 667.
667 as an option. Mr. Ward, what number did you have?
3,000.
3,000 as an option. Anybody else get another number? Okay. I had 3,000 after a slight correction after thinking about it. So I tend to agree with Mr. Ward. So we're going to let Mr. Ward explain how he got to that number.
So for every revolution of the distributor, you have two neutral positions for the magnet, which means that you have three different.
We got a gear between these two, so you
Yeah.
missed a statement there.
Yeah.
So I'll explain how, I was hoping he'd explain it better than me. All right, so here's how I would do it. The long way is I started with 2,000 RPM on my engine. I've got 6 cylinders. 2 times 6 is 12,000, but we only fire every other rotation. That brings me down to, I need 6,000 sparks per second. Sorry, per minute. I need 6,000 sparks per minute. You see how I got there? 2,000 RPM times 6 cylinders is 12,000, but they only spark every other is 6,000. So I need 6,000 sparks per minute. I have a rotor that only has 2 poles, so I'll take my 6,000 divided by 2. That gives me 3,000 RPM on my rotor. So we gotta put a 3,000 in there.
So you just skip the distributor step by going to.
Yep, I didn't even think about the distributor, I didn't care about it. You could do the distributor side, and you could say, well, my distributor is running at 1,000 RPM, and I know that it's gonna spark 6 times, so I could just do 1,000 RPM times 6, right, equals 6,000. So I know I need 6,000 sparks per minute, divide that by 2, gives me the same 3,000. So you can run the math from your distributor, you can run the math from your engine RPM. The distributor math is actually easier because you save a step. So either way you want to do the math works, as long as you do the math right. Which I originally forgot I had 6 cylinders. I was gonna give you 500 RPM, and I'm like, no, that can't be right. That can't be right. All right. There is a math question on the exam similar to that, and mostly, you probably won't get it from the FAA, but it's mostly to cement in with you guys that there's gearing, there's ratios going on, and what actually causes the spark. And if you understand what's going on in the magneto, you'll be able to get those answers correct. All right, we're gonna run through these pretty quick. Oh, there's a picture. The FAA doesn't give you a lot of pictures of 2-pole magnets. So which one of those is full register? Joe? trying to trick you. Those is plural, so I was still good. Which two of those is what I should have said. You guys have that Jepson manual online, I think. It's like a Jepson power plant. There's some images in it. It's not a bad idea. It gives you a couple different views, if you get a chance. What is this? That was my question. I don't know what the answer is. I'm just gonna pick a name and figure it out myself. Sam, what is this? Oh,
That's a mistake. Oh, this is the,
low tension system, very good. So we've got our primary coil back in here, looks the same as almost any other system. And then we send voltage from ground through our distributor back to ground. And that's our transformer, or we would call it our coil. Some places call it a coil pack, but right before the spark plug. So that is a low tension system. They just try to confuse you by throwing a high tension transformer in there, because the transformer turns my low tension magneto into the high pressure that I need. Amanda?
Is there a transformer for every spark plug?
That is correct. That's an exam question.
That's a lot out of date.
Yes, it is. So here is a low tension magneto distributor that's busted. I'm like, why are you showing a busted one? Well, because I don't have one that's not busted. So maybe I'll find one later. This has brushes in here that are supposed to have springs underneath it, and those springs would push the brushes up and they'd make contact with the actual surface on the back of here. What's pretty interesting is from where you're sitting, it looks like it's a solid piece of brass, but when I pass it around, you'll notice all but one are basically just there. I don't even think they're connected to anything electrically. They're just there, and they're there so that when it goes around, the brushes are still riding on something, so they're not going bam every time that the one comes around that the spark is on. The one that the spark is on will basically transfer from that plate, I gotta make sure I got my head on straight, out to, this is the magneto side, out to the spark plugs would connect to this. So you'll notice the wires are not insulated very well. Can I phrase it that way? It's because we're still low tension here. There's not a lot of voltage jumping around through here. So on a low tension system, this distributor actually uses brushes to make the connection and transfer the connection over. I believe this side would have a similar setup going to the oh, it's not similar, it just goes to the middle of this thing, where it's gonna come in. So I'm gonna pass that around. That's one of the ones. We got more, you can look at them later, but low tension system. Here's an image, what I was explaining. This one will be the one getting the spark, the other are just a place for it to ride, and you can see the brushes inside there. Cool. Low tension system. Okay. Where am I at? Okay. A couple more slides. Two-pole rotor. How many cylinder engine? How many cylinder engine? Let's make these quick. Man, Ava. 6-cylinder engine. Cool. I had some more math, but we did some math already, so we'll skip the math. What's the picture on the left? Marcy. Impulse coupler. Can you guys read the one on the right? Yes. What can you tell me about that magneto piece?
It has an impulse coupling.
It has an impulse coupling? Okay, I'll take that. Jediah.
Left-handed.
Left.
Rotation.
Left rotation, okay. Do we know what side of the engine it mounts on? Nope, no idea. The rotation doesn't tell us that. It just tells us it rotates, left rotation. Ryan, you got anything else you can tell me?
Oh, the lag is 35.
What's that mean?
Isn't that like, it's where it sparks, or it sparks before, 35 degrees before temperature? No.
That's incorrect.
Okay.
So that's gonna be stamped on the engine. So Corbin, help him out. What does that lag 35 mean?
It's gonna be some sort of degree with the coupling and all that.
Yes, yes. Help him out a little, Kurt. Fine tune that. Lag 35, some sort of degree with the coupling. Celine?
So it's supposed to spark like 22 degrees before it's 35 degrees afterwards, so it should be like 12 degrees after process.
Did you hear that in the back? Kinda. Alright, so if it was originally on the engine at 22 degree before top dead center, that 35 lag says we're going to delay that by 35 degrees. So when the impulse coupler is activated, the impulse coupler will delay the spark by 35 degrees. That's what that lag is telling us. Good. Alright. Ooh. We're going to get into this today. You know what, so I didn't teach too much about it. I'll just explain a little. This is a Bendix mag. It's got a little cam in here. It's hard to see. That's going to lift the contact points there. Notice, see the springs in there? So on a Bendix mag, the springs are on the mag side. Your harness doesn't have springs. It has the witch's hat on it. So Bendix mag. I'm going to show some pictures, hopefully. This wire is off. And sometimes when we're working on these, we do that because if I put my buzz box on here with the wire on, my buzz box is actually sending an amperage through the contacts and it's trying to make it back to the other wires, how it works, right? So we actually start sending an amperage through the coil, and if you try to do timing with that wire connected, depending on your buzz box, it'll really mess with you because you'll start magnetizing the coil and stuff starts moving. If you leave it on there long enough, it'll actually kind of change it gets weird. It gets weird. So disconnect your wire when you're doing the timing. Now take a picture before you do. Take a picture before you do because, let's see if I can get this up. When you go to put that back on, it's not abundantly clear which side of the magneto the wire goes on. In the manuals, if you have to dig for it, it will tell you, and it depends if it's a right rotating mag or a left rotating mag. If you only have one set of contacts, it makes it pretty easy, right? But most of these Bendix ones that we have around here have two sets of contacts, like the picture on the left. So, I'll go a little higher. It says the lead, or lead, I guess it's lead in this instance. English is a terrible language. The lead positioning, dual contact assembly, right hand rotation, it's saying for that one. It's always hard to know the wire coming out of the mag that goes to the contact itself. It's always hard to know which sides that go on, and if you disassemble these, you got to make sure you don't pinch this thing. When I put the second case on, one of the biggest problems we have with Bendix mags is those wires get pinched where they're routed, so we want to be really careful with that. But so I'm timing it, and then I go, oh, I forgot. Was it left was the main contact, and right was the retard, which way does it go? And it makes a difference which way it's rotating. This mag is a left rotating mag. The image they showed is a right rotating mag. So mine are going to be reversed. So this one, it's saying the retard is on the right if you have a right rotating mag. Okay? I wish I had a better way to explain this, but I struggle with understanding this, and this really helps me. This really helps me. Who's gonna have a harder time understanding which side it is? The normal mag or the retarded mag? The retarded, because they're a little slower, right? They're a little slower. So what we do is we make it easy for that fella, and if it's a right rotating mag, the retard's on the right, okay? If it's a left rotating mag, the retard will be on the left. So I'm technically accurate, and I'm not having any bad slang, because I used all the correct terms, and that's how you remember it. If it's a right rotating mag, the retard's on the right. If it's a left rotating mag, the retard's on the left. The problem is, normally you're asking where is the main contact, because the main contact is what hooks up the lead, right? So you guys got to be super smart and know what camp you want to put yourself in. We'll put it that way. Yeah, Randall?
Is the shower sparks thing a Bendix thing in the 15
I think it started being that way. Bendix trade named shower sparks, and then Slick did say, hey, that's kind of handy. We're gonna come up with our own boosted system. They'll call it either a boosted or vibrating points starting system. So you can get them on a Slick mag. So for instance, say you had an aircraft engine that had a Bendix mag, but it has a shower spark system. So when we say system, your key, your shower sparks box, your wiring coming to this is all part of a system. So you can say, I hate those Bendix mags. I'm pulling that off, I'm putting a Slick mag on there. So you can put a Slick mag on with a shower spark system. But Bendix originally came up with it, so we tend to call it a Bendix shower spark system.
And can you have, is there some impulse couplings on Bendix?
If you have a shower, let me back up. If you have a shower of sparks, you will not have an impulse coupling. Bendix do have impulse couplings on them. Yeah, shower sparks are a little more expensive. It's like high end. It's like, ooh, fancy stuff. We got shower sparks. Yeah. Okay, now I just lost my spot. So this is a left rotating mag. Left rotating mag means that. Okay, so that one's gotta go to the right. That's the camp I want to be in. Some days though. Okay. Here is a wiring diagram for one of the shower spark system for Bendix. We're gonna cover this after midterms. We're gonna cover it in detail, but me and Randall think alike, and he's like, wait, so this shower spark system, this one has a complicated ignition key because I've got a BO, and basically BO in my mind is Bendix shower sparks operate. That's kind of BO, Bendix operate. I don't know what they intended it for, but it works. It operates the shower spark system. But we also have LR, so the retard contact on the left mag connects to here. There's another wiring diagram that will work a system very similar that has a shower sparks box that has 5 terminals on it. You notice this shower sparks box only has 2 wires going into it. Do I have the right boxes? Oh, I carried it out there. Oh, here. So in my image, I have a Bendix shower spark system, starting vibrator system that has 2 wires going to my vibrator. There's another system that has 5 wires going to the vibrator, and these we will be able to wire into a standard ignition system. So we'll cover the differences between those next week after the midterm. But what you need to know for the midterm is either you're going to have a retard contact, and typically if you have a retard contact, you have a shower sparks, or you're going to have an impulse coupler to get it started. Now, if I had a system with a retard contact, but no shower of sparks, would it still work? Kind of. The reason it's not going to work very well is there's nothing to speed up the rotor of the magneto when I'm starting. So instead of having that quick speed, I'm just cranking the engine at and my magneto's not going fast enough to give me a good strong spark on startup. So you're generally not going to see a system with a retard contact without shower sparks. They might be out there, but the problem is the rotor speed is an issue on those ones. When we get into a little radial engine stuff, we'll talk about a similar setup where you can have a guy hand crank a device that sends out a shower of sparks. He's like, and then instead of a retard contact on the distributor, they actually just have a separate finger that trails the main one. So they have a retard finger on the distributor, and it just delays it that way. It's pretty genius, actually. Okay, P-lead. Okay, I need somebody to point out where my P-lead connection is. Grant, you want to circle it or give me the up, down, right, or left?
Let's do up, down, right, or left. I haven't taken mine apart, so this is gonna be rough.
Well, good thing this one's assembled.
Yeah. Okay, go up.
So the P lead is this right there. That's where we're going to connect the P lead to our magneto. Remember, it's the wire coming through the capacitor. So it's the terminal outside the capacitor. What we want to be super careful of is if our P lead that is on a ring terminal how's that for a ring terminal drawing? If that ring terminal comes in contact with our capacitor, and the shell of our capacitor is all of that hex, right? If our ring terminal comes in contact with the shell of that capacitor, our mag is continually grounded, which means it's never gonna fire. Never gonna fire. So we gotta be super careful to make sure that our P lead doesn't get bent down and touch that. To that end, oh, I don't know if I have them in here. We have a jar of washers. They're little, it's not plastic. What do we call terminal strips? Phenolic compound. They're little phenolic washers that do not transmit electricity. So typically on a magneto, you're gonna get a phenolic washer that goes underneath the terminal on there. So the terminal connection is actually making connection with the nut that you put on top of it, through the terminal, through the lead. We do not want that electricity to be able to hit the outside of our capacitor. So you gotta be super careful with that, because otherwise that magneto is not gonna fire. On a Bendix mag, I don't have one in here. On a Bendix mag, they do it different. It's a terminal screwed right into the back of it. So you have to physically disconnect. It's like a custom trademark fitting, I guess you'd say. All right. What you circled, Grant, was our vent cap. You circled our vent cap on the slick magneto that sat up top. So we'll have two vents on our magnetos. On slick ones, we have two. On Bendix, I believe one of them gets plugged. The top one gets plugged and the bottom one's open, I think, on a Bendix. So on a slick mag, we have two vent caps, one on the top, one on the bottom. The top one gets an umbrella so water doesn't fall in. The bottom one gets just some holes in it. And that allows two things. It allows the heat to get out, because it makes heat inside here. The heat to get out, and also the corrosive ozone and the other stuff we're making from the distributor to get out. So we want the heat out, we want the corrosive out. Everything, that's what we're trying to do with those vent caps. Question? Okay. On high altitude aircraft, when we say high altitude, you're like a jet that uses, well, I mean, when you had a bomber back in the day, or maybe you had a turbo, turbo, not being turbine, but a turbo powered, it's like a T210, has a turbo on it. Sorry, I stumbled across that a little. They can fly higher. Well, if we're up very high where the air is not very dense, not very thick, what happens in our distributor is that little spark doesn't want to go all the way through the wire to the spark plug anymore. It's like, ooh, I got places in here I can spark to, and it'll just start sparking inside the distributor. So what they do is they take the vents and they pressurize them with turbo air, and that pressurizes your magneto. So the reason they do that is to keep the spark from finding an alternative path to ground when you're up at high altitude where the air is not very insulated.
Where is that air thing going from?
Right into the vent cap. They will pull usually the top vent cap off, and it'll get a fitting that'll have a hose connection that'll go to your turbo.
So it's still coming out the other air then, it's just there's pressure.
I believe they put a tiny hole in the other one, yeah. That way it still goes through.
So the point is that there's pressure sending it out.
Yeah.
It's-
The way I'd phrase it is there's more pressure coming in than we're letting out, so it is a pressurized case at that point.
Yeah.
Yeah.
So what is the connection to the manifold? Because we want pressure.
When you pull the power back, the manifold pressure drops, but when you pull the power back, the turbo outlet stays pressurized. And probably a bigger deal, your manifold has fuel in it. And we probably, depending on the aircraft,
So then
we probably don't want to be putting fuel in here.
right, so it'd just be after essentially the air filter would be filtered for
Well, it's after the turbo is pressurized. So after the air filter, yes, but after the turbo, just the pressurized air.
So, Case,
Yeah,
so if air has a very high resistance
yes.
and less of it,
Less of it's less resistance.
means like in space, basically, we could get a spark.
It's a problem.
Jump like a mile.
I don't know if it goes a mile, but yeah, it's a problem.
But I mean, like in space, where it's literally a vacuum, we could get
Well,
a spark to go.
We did
very
this
far.
in basic electricity. Air has a value of 1. I don't know that space is 0 resistance. It's just,
But it's a lot. It's hardly any.
I'm not sure the math on it, yeah. I don't fly in space that much, but it is a thing. It's a problem. Okay, there's our contact points. Amanda, pictured here, has the little plastic or whatever piece that lifts the contact points as that goes around on your magneto. The main thing in this picture, it's hard to see, but this terminal is slightly turned, and the bottom left corner is getting pretty close. Getting pretty close to ground. We gotta make sure that terminal is straight, not turned at all. There's Dean. Hopefully he's gonna be back Monday. Right here, talked to him yesterday. And that's the break, 9 o'clock. All right, when you come back, I'm gonna say at 10 after, I'm gonna walk through a quick review on how to do a slick, and I'm gonna walk through 2 different styles of Bendix. Shouldn't take too long, because I realize you guys are tired, but it'll at least get you started. So take a break, come back at 10 after. The what?
Anti-gravity battery. So, what's supposed to build a battery that's like the same size as a car battery, but it weighs less than
So it's just a fun.
Right, sir, but it's like,
Doesn't float.
the average battery is, say,
What's it made of?
it's like lithium, right?
Okay.
And it's really expensive, but they're so like, if you pick it up with like, just
Aircraft? Aircraft what?
No, it's not aircraft, it's race cars.
Well, the problem with, so there's a place in Washington State that, stuff, and they convert their fleet to electric beavers, like otters. But the problem, they say they convert their fleet. My understanding is, one of the issues is the batteries weigh so much that, the devil plane can take a person. It's a one time. So, they're trying to, they have a couple, but that's the problem with the battery powered airplanes, is the batteries weigh so much that you've lost all your capacity.
Yeah.
So if you put batteries like that in an airplane, all of a sudden now you have an electric airplane.
Well, it's, just to replace your car battery, it's just a really easy way to do what a battery does.
So I don't understand
Start
how we
having
get
storage.
Why would I care in a car about the weight? Just race car?
Right, it's meant for more like race cars, but if like you have an aircraft and you want like 50 pounds out of the front of it,
Huh.
I just thought it was really.
Yeah, that would make a deal in aviation.
Yeah, I'm not sure they're using aviation.
I bet they're getting experimental stuff.
So it's almost like a, it's almost like a curve.
They start making, I'm gonna say, glider shaped airplanes. Because gliders don't take any power, right? Like, yeah, they glide, but you get glider shaped. I hope you can get a glider shape that's electric powered.
Oh, yeah.
You know, let's say 80, 100 mile an hour. All of a sudden you don't have- What's up? Just hanging out. Okay.
Hanging around.
Good, I guess, to take all.
Growing the hair out.
Yeah, a little bit.
It looks good. It looks good.
Yeah.
How long, is this just waiting to get a haircut, or are you gonna go with a ponytail at some point? Oh, okay.
No.
Man,
I'll pass on
Oh,
that.
I'm getting a haircut tonight.
I can see John with a ponytail.
I think John would look great with ponytail.
Yeah.
He had his hair down to his shoulders too. Maybe a little pink bow tie.
Tarzan style. Oh, yeah.
Usually looks like Tarzan.
Not a good way.
There's guys that are
the best review I think we've ever done. You agree?
Yeah.
So it wasn't just me?
Yeah, well, it wasn't even well, it was a review one, yeah. Yeah. Part of it is with that chain of events of how they work, it's very difficult to teach the whole chain on one day. So, like, we've been giving you pieces and ingredients, so today was kind of a wrap up. Okay, we have taught you all this, now let's make sure we can put it together. All right, I got 5 minutes yet. your students, explaining to him why SMAT is the best place in the world to get trained in missions aviation.
Samaritan's best.
I said SMAT, didn't I? Yeah, that's right.
Okay, sir.
I always like saying that, and people look at you like, how can you say that? And I'm like, 1 year, we try to say missions ready, most of y'all, missions ready. 1 year, missions ready, and you see all the mission orgs. So that's a rare thing around the world. Joe?
Yeah, so according to AI, whereas Earth is 14.7 psi, standard atmosphere,
Okay?
space is 0.17 zeros 145 psi.
Okay. Oh, so there is something. Okay, keep going.
Yeah, there's a little.
Okay.
There's a-
I thought we were talking electrical though, so keep going.
No. But the breakdown voltage decreases as we go up in the atmosphere. There's
Yep.
less density air.
Yeah.
But then once we go into a vacuum, it goes back up exponentially.
Oh, it's just a vacuum.
You can't get as far.
There's nothing to go through.
The electrons travel
Electrons
out.
You just don't get nice big flash. That's why research don't work in space.
Okay. That's it, yeah, because that's a vacuum tube. Yeah, okay.
That's why they use oxygen tanks on the first before you
Yeah.
change.
Okay. Bendix mags. There are four different Bendix mags that I know of. There's 3 main ones. I'm going to say 3 main ones. And when I say 3 main ones, you've got a 20 series, a 200 series. Oh, there's 4 main ones. A 1200 series, and I think there's a 2000 series. I'm going to say a question on that one. You will see, we'll talk about the 1200 series. You will see the 200 series. The 20 series is basically, I have this right. The 20 series is basically I think it's a 200, but with no retard contact. But similar. Anyway, point being, you want to make sure that you have the manual for the correct series one you have. So for instance, this guy is a S6RN-205. So 205 fits in the 200 series. So like basically from 200 up to 300. So when you're doing the mags, you gotta be in the right family. This guy is a, getting hard to read, S6LN-1206. So he fits in the 1200 series family. So it's a 1206. So the S6LN, the L says left rotation. This one's a S6RN, the R says right rotation. That's just something that you kind of have to have memorized is, I got an L or I got an R in those first 4 digits. That's telling me, is it a right or a left rotation? I believe the 6 is telling you six cylinders, right? So 2 of those 4 letters is just how it operates, and I'm sure the other ones mean something that I don't know, and we'll have to deal with it. I'm going to do a kind of quick internal timing on my slick mag. Oh, except where's my half moon thing? It's gone. I might do one. See if I got it. And then we're going to spend a little bit more time on the PowerPoint doing the internal timing on the Bendix mags. It vanished. All right, we might have to fake it. Fake it till you make it, they say.
Where did it go?
Somebody didn't steal it, did they? All right, so we'll just step through. Slick mags are pretty easy. You're going to take the 4 screws off. See how fast I did that? That's impressive. Right? Oh, I know. Who is my videographer? Come on up here, will you? Woo!
Hey, dear Case,
Yeah,
also,
I like it.
just so you know, Zach was correct, recip engine would work in space. Your turbo would have to be the size of the moon to run a LICO.
Or you'd have to bring oxygen with you. We'll deal with that in fuel metering class. Alright, so here is our slick mag, and we need to be able to get to the points to make this adjustment. distributor on, I can't put the half moon tool in there. So let's see, Heat Heist, you look like the fastest one in the corner. Can you grab, you know those half moon crescent things that I'm gonna stick in here for timing? Israel, do you know what I'm talking about?
Yes.
Can you grab one out of one of the mag boxes? Wait, we got it, hold on, I knew I had one, sorry. This thing, I call it a half moon, I call it a crescent. Thank you, good eyes. I should, you know, at the end of the year, if you're not going to a mission org like Samaritan, we might need, we might need a lab assistant. It's a good place to learn. Okay, distributor comes off. Oh, I learned an interesting thing on a video that's on the end of this lecture that I'll tell you later. Instead of putting the pin in, when the guy puts the distributor back, he goes in here, essentially puts the pin in and he paints his two teeth. And then, I don't know if I like it or not, but then he actually sets in this, and he had his teeth painted so that he knew which one, and he set that in to match the teeth. I was like, that's interesting. So, interesting tip, we're not gonna watch that video, but basically it'd be the same as pinning it, and then he added the top. So, you know, there's different ways to do this than the manual, but as long as you're doing what the manual says. So, okay, so we got our contact points. I'm gonna pull the gear off, just so we're all looking at, as best we can, what we got. So, as my points rotate, it's gonna open and close the contacts. So opening and closing geese, can you tell? I'll go to the highest lift. They don't look very open to me. Do they look open to you guys? Not open. Somebody messed up our magneto. This is a bad one, so now we gotta re-internally time it. So, I'm gonna slightly loosen the two screws. I actually tend to loosen them and then go just slight, so they got a slight drag. I gotta hook my buzz box up. Is this gonna be the right or left mag? I don't know which color to use. Does it matter? Not really, it's a half joke. We'll make it the right mag, green wire. Okay, on a Bendix, I told you wanna disconnect that coil wire because it really messes with you. You can disconnect the coil wire, you don't have to. We'll do it, just because we're talking about it. Okay, and turn this on. It should beep and give us a color when the contact's open. I can test that. Okay, so we're definitely not open yet. So I gotta get my half moon shape thing, and I'm gonna have to find where the hole is. This is a left rotating. Gonna find the L. There's my L. I'll get it in there and then I'll get geese to give you a good picture of it again. Maybe. Come on. Sometimes these they jam in there real nice where you want them to go, and sometimes when you jam them, they act like they want to fall out. And I'll admit, that's kind of like, so everybody see? Flashlight. You're holding my flashlight. It is hard to see in there, isn't it? If you guys see what's going on, we got it in there, it's in the hole, and it's over in the corner. Ooh, okay, so that is exactly the point I want my contacts to open at. So I'm gonna come back in on the far side of my contacts, where that little flat thing is, and I wanna say, okay, you should be just barely opening there. Very nice. Oh, I think my battery's going dead. That tones. Oh, and you notice when I tighten the screws, oh, it changed slightly, right? So I might have to tweak it as I go. Alright, good. So I just internally set my timing on a slick. Pretty easy, right? That's smart. We install an extra switch to turn the beeper off. Alright. One tip that I've heard that the manual doesn't say. And this one might make me a liar. Yep, this one's gonna make some of the rotors, there will be an indicator on the bottom that you can line up. It doesn't work on all of them. So basically, they came up with some rotors, and they're like, you know what, that tool is kind of funny. We can give you a little notch, and when your notch is lined up, oh, wait, I just didn't find it. It's right there. Oops. See if you can. Might need that flashlight again. So right at the top of there, you see that little tiny speck that's sticking out? I can see it. I'm wiggling it back and forth. Oh, it's actually where you put the little tool in there. So anyway, when that's right at the right spot, that should be also where our contact points are opening. So I'm not going to have my little tool in there now. I'm just going to throw this back on and say, where do I see the, I'm going to do it this way. Where do I see the little piece showing up? Oop, oop. It's slightly off. So there are guys out in the field that have found those little tricks, and they'll be like, oh, you know what, I don't have to do that half moon thing. I can visually look at my rotor and check it. It only works on some rotors because some of them don't have the piece in there. The manual says to use this, and that's going to be the best way to do it. It's just a hassle. So that's internally timing a slick mag. Everybody tracking with us and say, yeah, I can do that. Okay, good. We're going to set our slick mag aside. I'll take that back because I know better than to try to internally time a Bendix mag with you guys watching, because it's a 15-minute, half-hour process if you're in the right frame of mind, and I've been lecturing for 2 hours. So we're going to give you some slideshows instead. Bendix mags. Move this back so I got my right area that I'm looking at. Basically, oh, that's the next slide. Basically, there's 2 different styles of Bendix mags. One of them has a smaller cam, and it has a notch in it. If we were to take this screw off, which I'll do in a minute, and look at that, that cam can only go on there, now technically 2 ways, but it can only go on there 1 way. The ones that have a bigger lobe, there's actually a tapered piece. So when I take this screw out, if I use a little pressure and pop that off, there's no keyway to set that lobe on the magneto rotor. It's just wherever the installer puts it back on. These ones are pretty easy because the only adjustment we have is we can move the points, kind of like a slick mag. This one gets a little bit more complicated because I can adjust the points, but I can also adjust where the cam sits on the rotor shaft. When you're all done with a Bendix mag and you're complete, basically you'll go back and you're going to ask 2 questions. You're going to ask, when do the contact points open? Are they in range? Because there's going to end up being a range they give you, because they're, in my opinion, I don't like them. Dean loves them. I don't like them because they're complicated to set up. But they'll give you a range of when the contact points open. It'll be like 8 to 16 degrees. It's a pretty big range. And they'll give you a range on how far open your contact points are when they're sitting on the highest point of the lobe. It'll be like 12 to 20 thousandths. Now those numbers change based on the model magneto you have. So it's not something most people can just memorize. It's you got to get in the book on the page and say, hey, what was the range for this one and what was the opening point? The book, when you go through it, is a little tricky because it assumes your contact points are good. So it'll go in and have you put the lifter for the contact points on the highest point of the lobe, and it'll have you set how far open they are. So you actually set how far open your contact points are with a feeler gauge. It's almost impossible to get in there with a feeler gauge. I had to like cut, it's a hassle. In the real world, people that do these all the time, I believe, from what I'm seeing, is they get their eyeball calibrated to where they know what the correct opening is. And before you laugh like Job just did, when you start doing spark plugs and you get good at them, the gap allowable is 16 thousandths to 22 thousandths. And when you're good at it, you can see that with your eyeball. You can be like, if you handed me a whole line of spark plugs after this class, I could tell you good, 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 bad, bad, good, bad, good, bad, good. I can get my eye calibrated to that. These contact points, I think in the real world they become the same thing. Because if you're gonna do it according to the book, you're sliding a thin feeler gauge between contact points that move if you put enough pressure on them. And it's just like, oh my word, these are about impossible. But once you get your eye calibrated and you know what you're doing, it's not so bad. You put it up on the high point, you adjust it so that it's the right opening, and you're like, yeah, that's 20 thousandths. I can clearly see that, right? So you're gonna put it up on the highest point, adjust the contacts, then you're gonna put a little needle on here, and you're gonna say, okay, now that I'm on the highest point, when do I actually open the contacts after neutral? And as long as it's within a range, we say, okay, we're good to go, let's put it back on the airplane. What happens here with our old magnetos that are shot is usually something's off. So we put the contacts to the right opening, and then opening distance, and then we put it on the lobe, and it's not opening at the right angle. And then the Bendix manual will say, okay, well I tell you what, we'll give you a fudge factor, we'll let you now open or close your contacts just a little bit more or a little bit less to adjust for that, to get your opening point in that 8 to 16 range, or whatever number they give you. So they actually give you a range that you can mess the other thing up by in order to try to get both of them to be in the window. So kind of picture it like we've got a mark that here is where I want you to be with the contact opening, and here is where I want you to be with the degree. That's the perfect world. If yours don't match that, I'll let you shift one or the other, because if I adjust one, it adjusts the other. I'll let you adjust them as long as they stay within this bigger window. So when you read through the manual, it can get kind of tricky, because you're like, I already did that step. Well, we're going back because you didn't fit the original window. We'll make sure you can fit the bigger window. Is that kind of making sense? It's kind of like do I get to talk about the Corvette after I sold it? It's kind of like my Corvette. You say, I wanted to get 27 miles per gallon with that, but I mean, once I was committed, 22 was good enough. So I tried for the better number, but yeah. Now if I was under 20, you're just bad and you gotta toss it. So it's the same kind of idea with this. They want you to try for the best number, adjust the other, and then they'll be like, well, as long as you're somewhere in the range. So with that said, what a lot of people will do is they'll go in the wrong order. Instead of adjusting the contact opening points first, once you get in the field, they'll say, you know what, we always end up erring on one side, so I'm going to adjust it so that it opens at, let's say the maximum degrees is 16. They go, I'm going to adjust it so it opens at 14, because I know that's going to put me in range on the other one. So you can do it in whatever order you want. I recommend following the manual, because that's what we teach. But as long as when you get done, both are within the window, you're technically okay. If you want to spend an hour doing each one, you might be able to get them both. If you want to spend a half hour doing each one, you'll be happy to just get them both in the window. So with that said, we're going to go through a couple differences between them. That first slide gave me rough numbers on an S20. You'd set the gap to 18 thousandths plus or minus 6 thousandths, so that gives us 12 to 24 thousandths opening distance. So you'd set that and see what you get for timing, and the timing would be between 6 and 14 degrees. If I went to the S1200, I'd set it to 16 thousandths plus or minus 3, so it's a different number and it's a tighter window. Then you're going to adjust the timing for 15 degrees for a 4-cylinder engine, and 12 degrees for an 8-cylinder engine. So I'm giving you some numbers I don't expect you to memorize, but I'm telling you so that you go, oh, I'm probably not going to memorize these numbers. I better check the book to see where all the degrees are on them. Now, last piece before I go with specifics, A lot of them at SMAT, we're doing these with the retard contacts, the second set of contacts. What we do on the retard contacts is we get the initial contacts, our main contacts set correctly, and it's all set, we're within tolerances, so the magneto in the aircraft is running in cruise is gonna be running correct. And then we go, okay, now let's go back and let's set just the retard contacts, and we're gonna set it for when we start the aircraft. So the retard contacts, what they do is they say, okay, now that you got the main set, we're gonna re-add the indicator needle, and we're gonna set the needle at 0 right when your contacts open. You had to go through all that stuff to figure that out, but right when they open, we'll set the needle at 0, and then there's gonna be a certain degrees after 0 that the retard opens. So remember on a impulse coupler, it says on the side, 35-degree lag or whatever. On a Bendix mag, it's actually stamped right in the bottom of the magneto. It's cast down there. So your retard contacts are always gonna be whatever numbers in the bottom of the magneto past what the initial contacts were. It's past what the initial contacts were. Don't do it past neutral, because you would be wrong. Because the main contacts might have a range. They might be 6 degrees after neutral, they might be 14 degrees after neutral. We got a range. We want the retard contacts to be whatever is stamped past the main. When you mount this to an aircraft, you're gonna mount it on there based on when the main contacts open, and you're gonna forget about everything else in the middle, right? And you want your retard, your delayed contacts to open that number after when the main contacts open. So the retard is based on the main contacts. Question, Cheddar?
Yeah, you said the lag was stamped, is it on the outside of the case, or do you have?
It's right in between the contacts and the bottom.
So it's
And-
inside?
Yeah, yeah, this picture has it right here. See the 30? So this has a 30-degree lag between the main contacts and the retard contacts on this one. In the manual, they do give you a chart, and you can all look it up and stuff, but it's kind of silliness because it's stamped in there. And it will be what's, I guess, cast or depends on cast or stamped, whatever you want to do. Okay, so we're gonna go a little slower on the Bendix S200. Okay, good, and the S20. Basically, the 20 is a 200 minus the retard contacts. Internal time. The manual says, if you go through the steps, we're gonna set the gap of our contact, our main contact, to 18 thousandths, plus or minus our 6. And that is when the lobe is pushing on it at the highest point. So you'll still loosen this screw slightly, loosen that one, remove the wire. Now the wire should be on the main contact. So we talked about this before break. I got a wire over to the right-hand side, so that would make, if it's set up right, this would make this my main, and this my retard. So what rotation is this mag? It's a left, because the retard contact is on the left. And we make it easy for that guy to figure it out. So this is a left rotating mag based on that information. So we want to go to the main contact on this left rotating mag, and we're going to turn the rotor until it's up on the top. The instructions basically say you're going to mount it this way, and there's a tool that you can clamp the rotor at the neutral position, and then you can flip it over and you can put your things on there. And then you have to loosen the clamp to move the rotor. Part of that whole clamping thing is your buzz box. Remember how I talked about it messes with magnetism? If you don't clamp it, it'll tend to just kind of move around on you a little bit as your buzz box does stuff. So you don't have to clamp it. Most people don't clamp it. I've only seen one person in the history of SMAT clamp the thing. Most people keep their other hand down below and they hold on to it so that they can spin it. The video I gave you, the guy had it looked like a pretty genius idea. He just took the shaft and he put it in a vise. Now you want to protect stuff so it doesn't get busted, but he put the shaft in a vise, and then when he wanted to turn the rotation, he would just turn his whole magneto. That was the first time I saw that. I said, hey, that looks like a pretty slick way to do it. You turn the magneto and it wouldn't be a slick way to do it, would it? It wouldn't be a slick way, because it was a Bendix. Okay, so back to S200, S20. Set the gap to 18 thousandths. And then see what you get for timing. I got a typo there. Should be between 6 and 14 degrees. If it's between 6 and 14 degrees, we go, cool beans, I'm moving on. I'm gonna set my retard to the gap, and then I think it'll give you a number to make sure the retard's opening the right distance, but actually I don't even know if they care on that one. That's what the book says. If that's not correct on the timing of it, you'll have to basically go back and put it, like, let's say you set it to 18 and we were at 16 degrees later. You'd be like, oh, I'm outside. Okay, I'm gonna adjust my contacts so that I'm just barely inside 14. And if that's the case, I just messed up my gap, and then I gotta go back and make sure that the gap is still good. So basically making sure we hit both windows. Actual practice tends to be, we're gonna go in and we're gonna set it so that it opens at 10 degrees, and then we're gonna check our distance to make sure that I fall in that range. That's the easier way to do it. And if it's not in that range, I'll tweak it and I'll go backwards. It's easier to do it this way, but you can do it whichever way you want. This is the one that has a lobed key, and I'm gonna show you that right now, and then we'll switch magnetos. Screw comes out. You know what? Geese. My video man. Hey, we're still going. We're still live.
15 minutes.
Alright, if you look in here, you can kind of see the keyway that's going through there. It can be pretty hard to pry that bad boy up. Oh, it went up easy. Whew. You'll notice, I'll stop there, can you see the arrows on here? So, I have a right rotating mag, so the arrows are going the correct way. If I happen to have a left rotating mag, I could flip that upside down, I believe. Yeah. Now that cam would be installed the wrong way. It's actually pretty wore out, you can't see them. So right or left rotating is going to take the same cam, you just got to install it the correct way. So that's one other thing while you're installing these to watch and see what you got going. So that has a, I don't know if you can get the little keyway on there. Oh, it's hard to see with the shadow. Ooh, there we go. Maybe. There we go, it is. There's the key. So that can only go in one position on this shaft, with the exception of I can be upside down, but I gotta make sure those arrows are matched up for what rotating my mag is, which I just forgot. So that's that way, so I gotta put it in this way. Okay, now, you guys don't have the, oh, see, I gotta put it in the right spot. You guys don't have the luxury that I do of being able to feel this thing right now. It's kinda sticky. Why I bring that up is, oh, that's not gonna agree with me. I might just leave it there. There is pads inside here, little felt pads that should have oil on them. I'm gonna set this guy aside and deal with it later. Oh, you need the pads though. See these little felt pads that ride on the rotor? And when you do them, you'll see them a little bit better. Those have to be oily. The test in the manual actually says you touch them with your fingernail, and if your fingernail comes out wet, you got enough oil. If you touch them and your fingernail doesn't come out wet, if it's just tacky or it didn't absorb anything, I gotta put another, and they'll give you a number of drips, a couple drips of a specific oil. We had a jar of it, and I think it was in the blue plastic box with all the mag tools, and right now the bottom of the blue plastic box is oily. So something happened between last year and this year, and somebody stole our oil case after they spilled it all over the tools. So that is one question, and I think they even have that one show up in prepware, is they'll say, how do you check if there's enough oil on the felt pads? And it's the fingernail test. You push with and see if your fingernail comes out oily. Alright, that's as close as I can get for now. Don't go too far. We're gonna switch over to the other mag, the 1200 series mag, and gave you the manual. The manual will say set the gap to 16, plus or minus 3. We got a bit tighter tolerance here, a little harder to check with your eyeball. Adjust for timing, and 15 degrees for 4 cylinders and 6 cylinders, 12 degrees for 8. We don't work on a lot of 8s, so if you're gonna memorize something, 15 degrees is normally, and that timing is after neutral position. What you're gonna do is you're gonna have your mag up here, and you're gonna go until you find where neutral is. Oh, there's neutral. Now here's the part, if you have your buzz box on here, it's gonna be very hard to find neutral because you got electricity going through your coil and it messes with you. So have the wire off or have your buzz box off, but you're gonna find the neutral position, and I'm gonna show you this on this one. These fancy tools that previous year students made, and you guys can make if you want to, or we have them in the kit. Just goes on the screws like this. On the other mag, I could have used it for doing my timing. I would put it under those screws. And then the other piece goes on the screw to the rotor, and it's the same on both mags. So now when I turn the rotor, it's telling me how many degrees I got, okay? So this mag and the other one, you would find neutral. So there's neutral. You're gonna turn just the indicator. Yep, I'm still in neutral. Alright, so that's the tool you use for how do I know how many degrees after neutral I am? Well, we found neutral, we put the thing on, we put the indicator on, and we would have our buzz box, and I'm gonna go the correct rotation, and the contacts should just open. So for this one, it was 15 degrees, if it's on a 6-cylinder. Our last one, we said it was somewhere between 6 and 14. Halfway between there is 12, 11, 10. It'd be 10 is where you would, if you're shooting for the middle. All right, so back to this 1200. You're gonna set it for 15 degrees, so you're gonna get those contacts adjusted, so when it's at 15, all right, I got it right at 15. If I tried to do it, it'd take me 20 minutes with you guys staring at me, so we're simulating. Right, all right, good. Tighten that main contact down. Now, the problem is, I've got to adjust the lobe to get my timing on this. This lobe is adjustable. So if I take the screw off of this one, oops, and this is where it takes absolutely forever if people are watching you, so we're not going to do it. I'm just going to show you how. Screw comes off. Geese, you want to help? Sure. It'll help a little. This lobe is just tapered on here. Let's see, we'll get back to Apple TV. It was sitting in the middle, just like that. When I take it off, you'll notice that's a tapered shaft. So when I go to put this thing back on there, I can have it on and I can spin the shaft. I don't know if you'll be able to see that or not. I can spin the shaft and hold the lobe in place. So first I set my contact opening, and then I'm going to try to come back on the main contacts and be like, okay, now I got to figure out how to get this guy in just the right position so that when I have this on, and I've got my needle on, that screw would have to be tight, that it opens right at the 15. So tapered lobe makes things complicated. All right, you can have a seat. So they're saying set the gap, adjust when it opens, and then if your gap's not right, go back and adjust the lobe and try to get inside both windows. In practice, what happens is instead of using this little tool here, this one has a nice window in it, and in the bottom of the window, I think I have it, yeah. In the bottom of the window, there's a little line. there's actually two little lines on each side of neutral, which makes sense, right? Because if it's right rotation, where the contacts open have to be on one side. If it's left rotation, where they open have to be on the other side. So if you're just looking through the window, you get two little lines as an option. So instead of using this fancy little finger thing and trying to get it and everything's working against you, in practice, guys will go down into the bottom and they'll get that line lined up with the right one. They'll clamp it in place with the clamp and they'll make their adjustment for their contact so it opens right at that line. And then come back and make sure that when they're all done, the opening distance when it's on the high point is in the window, and when it opens is in the window. And then after you get the main contact set, you're gonna go back and say, okay, I got my main so that it opens right at the 15, and then I'm gonna leave it at the opening point, move my indicator to 0, so that now my indicator points at 0 and my thing goes beep, 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 at 0. And now I'm gonna go all the way up to whatever's cast in the magneto. This one says 37, and I want my retard to open at the 37. Okay, this is the last slide of the day, and I'm just gonna basically throw this hand grenade in and then dismiss it. Oh, it's a fun one. This is a radial magneto. I'm not gonna teach you how to internally time a radial magneto, partially because I don't know how. That's just to be honest, I don't even know if you can adjust it. So the rotor on this thing gets geared and it's coming around, or the distributor, excuse me. So the timing ends up in the back of them. There's a set of contact points that ride on a lobe here. So if you were timing them, you would be doing it based on the lifter back here in the contact points. And you'd get that timed and set up correctly. And we'll cover this device a little bit more when we cover radial engines. All your wires would hook to here. If you notice that big harness out there, the wires are still connected to it. We'll cover that more. When I go to time this to an engine, we got internal timing back here, and then timing it to an engine. This is gonna bolt down onto a big flat surface. So I'm not gonna be rotating it like I am a Bendix or a slick magneto on a opposed engine. So this guy is gonna have these vernier couplers, they call it, vernier couplers. And what they do is if you were to look really close at where the teeth are, they don't line up with each other perfectly from one side to the other. Well, they might at one point. But so when I go to time this guy to a big radial engine, I'm gonna get it where I think it's right, connect it to the engine, hook up a timing box, and if I'm, say, 3 degrees off, the manufacturer will tell me, okay, if you're 3 degrees off, pull that vernier out and turn it 3 teeth, or however many teeth they tell you to turn it, and you put it back in. And it changes the relationship of where the teeth here are to where the teeth on the engine are. If you get a chance, look at these, and if you can figure out how that makes sense in your head, good for you. All you need to know is how we adjust a radial engine timing to the engine is with a vernier coupler. Is we're just going to pull it out, move it however many teeth the manufacturer says, put it back in, and that changes the timing. Basically, one rotation of the this would be the rotor. One rotation of the rotor here is going to get me, I think, 4 sparks, and then we're geared to, this is a 8-cylinder radial engine. So there's 8 little divots where that contact point's going to open on that side. So a small adjustment on the rotor side makes a big degree difference. So that's a radial. Here is a video we're not going to watch today, but if in your own time you want to review, he does a
Now remember, just like all the other videos, this is just a guideline. Make sure you use your book. We have the points out. If we could, in case we're going to try to reuse them, we need to take them apart. And
He switches over to a Bendix, and this was actually pretty interesting.
That the bevel tooth with the red mark on it is in the middle of the sight window, or they call it a vent window.
Now, you see he put his needle on. I'm going to go to where he...
Once we get that done, I'm going to check it. I retard it. And again, we're going to see when the light comes on. And we want it to be at the 10-degree mark.
So anyway, you can watch that if you get a chance. Other than that, it is lab time. Dismissed. Questions, Cheddar?
Can you just go back 3 slides? Forward one.
I think you guys have this PowerPoint as well.
It's not available.
Okay, I must have changed something, because I actually opened it in my office this morning. I was like, I'm gonna make sure they have it. All right, I will go open that right now, before lab, again, for the second time today. All right. It's Thursday today? I haven't heard from Nick, Devos. Hopefully I have time to. Good news.
I got so many questions. I was like probably the most prepared in the electrical section. I had 80 minutes. Like wholly expensive. My worst category in my memory was hydraulic and fuel system. Yeah, I got hydraulic, non-metallic structure. Anyway, it just like it hit my worst category. The questions I've never seen. And yeah, Shane got a 96.
Nice job, man. Oh my god.
It is really.
What?
I really wanted to come back next year. I'm counting on you. Yo, our man has a problem. It's kind of funny though. I'm not gonna lie. Yo, he's doing the interior too.
You also missed something very funny during
Bro, we did. Yes. Yeah. How do you know? I was here. Oh. No, they got their cable all the way back in this podium up against the thing. Back like 4 feet before he did this.
Well, they're already out of place for normal, so like on a normal day that would probably show up, right? But we're already 2 desks.
Say what now? Yeah. My study worst
What? Yeah, go for it.
Going through those questions, I got like
Yeah, so on this one, as you turn that, this is actually where the spark would come out, if you will, and then travel to the spark plug at each cylinder. And then the second set that's behind it, I'm not sure if you're on the right way or not, I'll just say you are. The second set actually will get hooked up to a start booster, and on starting, they'll have a high voltage, so it's a little bit delayed, because we don't... No, so it's spinning slow enough that the magnet would be making a spark on this one. It's just spinning slow. So, because until that magnet really gets spinning up, it won't make enough voltage to spark on this one. So we'll do it to basically, you're delaying it. Normally on an engine, we want the spark to happen while the piston's still coming up just before it gets all the way to the top, so that it lights it, goes bang, and then pushes it back down. When the engine's running fast, that works. When the engine's running slow, if we were to light it before it gets up, it would try to kick it backwards. So
It has to be traveling down when it lights.
yeah, so what we do is we delay it when it's starting so that it's just a little bit later than it normally is. Yeah, this particular lecture was probably the worst one to sit in on. As far as like info, half the class is like, oh, today.
Marcy's getting brutal.
Let me go back to this one. So there's a magnet inside there that's going to be the same as inside here. And the magnet is actually going through a housing that has a path for the flux, the magnetic flux. And when you get to where it feels like it's grabbing something, we call that neutral position. Basically, there's no magnetic flux running through our coil at that point. So you can actually have some resistance. Yeah. It's a little trickier than that. It just happens to be how physically it's laid out. So that's what you're feeling.
So the crest is open, not
probably neither.
Feels like you're going
So when you get to where there's a bump, like you actually go uphill and there's a little bump and then you go back down. There should be. There is on this one.
yeah, there's like a slight bump in between the big.
Yeah. So that slight bump is what we call neutral position, and we want to open the contact points just after that. So this one's set up right. So you can feel where the bump is when you're going. So this one would spin this way actually. So just after the bump is where it should lift that. Now, it might not be adjusted right, but we're in the neighborhood. Yeah, they're pretty cool. The problem is we just got done teaching real electrical class, and the electricity in these, like, it's a different set of rules because we're only creating a spark. It's just an instantaneous. So all of we're not doing the whole Ohm's law. It is a circuit, but it's just once. So we're not doing the whole Ohm's law of amps and resistance. And, we're using kind of a different layer of logic for what we do with magnetics.
So is this like a resonator?
Yeah, I don't know what the name is.
Because it's insulating, right?
Yeah, it is. Yep.
Did you ever run into like cracks where it starts like bleeding?
So I have never worked on an airplane with one of these. Those are big radial engines. But yeah, on our smaller ones, like this, here are the coils out of our smaller craft. So this one looks like it's in decent shape. That one, obviously, that's bad. And this one, I don't know if that was bad.
Guys, I just want to check on your list.
Yeah, let me double check. Looks like Amanda, you're up first. Amanda Joe Tiki's. Yeah, there's probably a couple laying out in the parts box. We had a harvest one out, an apple crates out back. We could harvest one there. They're pretty much this. So they should have, do they have a number for us? This one just has a date. The tabs are a little bit different over the years, but we've been taking apart the same. Yeah, and I'll help you. The ones in here, I got a variety. The ones that are out there and or in the apple crate, if we find like the same problem with the magneto, pull it apart and harvest it.
And I just need you to, so I can explain it.
Yep, sounds good. Let me shut this down, I'll clear that off, and then I'll be out. So what are you doing in life right now? A what?
Auto mechanic.
Oh, nice.
Yeah.
So a lot of this stuff will kind of transfer as far as tooling. And what's interesting we have is we get people. And the first part of the year, they really do well because they understand how to use wrenches. The second part, the second half, if they're not careful, they can actually get by. They can get passed by the rest of the class. And the reason is there's so much aviation that can go by the book. that's a big part of teaching aviation.
That is a big appeal to me. Flat rate, you only get paid for like the book hours. So the more book hours you complete in the day, the more you get paid. That's a big push for that like skipping stuff.
This is
Truly insane. Gaskets not using the flat rate.
So that stuff exactly is,
Not bothering to pick up in the
people that struggle at SMAT are the ones that want to just tighten that up without a torque wrench.
because it feels tight if you're torqued.
Yeah.
Yeah.
Or under.
It's insane. Yeah, no, that's the other thing. Now, is this contacting the power supply to the
Spark plugs.
So this is
no,
power
this
going
one is
in.
actually, I'm sorry, I did see your point. This is actually the booster that lines up with the dragging one. So whatever way this is going, that actually would connect to the dragging one. So that's booster coming in, yep.
Okay.
The power to the spark plugs is gonna be connected to each one of those. And that gets added to this, basically coming off that coil. If you were to look really close, there's either a connection or a gap there. Must be a brush that runs.
Like right here.
Yeah, the very center of that shaft is gonna, basically, if you imagine this being in there, it's gonna have an electrical connection.
Oh, so these are
They're
equivalent
similar.
items.
Very similar, yeah. Yep.
That's it.
Israel. Yeah, I got Amanda Job TVE's, Isaiah, Israel.
Mr. Ryan, Mr. Case, sir, you can take me off the list.
Okay.
Dear Case.
I like that. I don't know. I should smile the same with the mister, right? But,
What would you do if I switched it around?
case mister?
No, case dear.
Case T.
It's been moved up by 55 minutes.
I laugh.
Good luck. Oh, I can't take my safety glasses in.
You know what? If somebody has Devos,
Safety first, last always.
here's how I'm gonna
Yes,
clean up.
they do not
Do
allow
the rest at lunch.
outer wear.
Sparse.
That's so sad. In testing facilities. They don't allow keys or handkerchiefs.
Wait, you can't wear clothing when you're testing?
That's what I asked. I go, maybe I don't want to be a pilot after all.
Take it back.
Because but if you read through it, which I have done multiple times, it says you can't wear outerwear, and I go, Dad, I want to wear my outerwear. But he says, no, that's just like coats and jackets and stuff. I go, oh.
So, underwear, you can wear your underwear, you just can't wear outer.
You can wear middle wear and underwear, just not outer wear.
Is it?
Details like
Yeah.
Oh, yeah.
Oh, I think I can take what's on my belt. I don't know. I always get really confused. You can't take like anything in. I could hide stuff in there.
That's right. Sneaky answers, grab, underwear.
Oh, my water bottle.
engraved on the plane. How much detail would it take you?
Ask not what your country can do for you, but what you can do for your country. Yeah.
Might as well just study.
Bad.
Okay.
Good luck to you.
Thank you.
And your organization.
Oh, I still have
Well, mess it up again. We did it repetition, baby, repetition. So better and better and better. About the other day. And I think your driver's license. I don't have an answer for you. Sir, I'm sorry. Alright. Let's get this one first that you can. Basically, just had like a shadow
separate, quiz for later, and I reviewed those a couple times. Got it. If you're just taking practice, like, take one practice test. Forget about that. No prep work. No study session. Yeah. Ooh. What did you get? That was 96.
Oh, no, really? Wow.
You got like one or two. So it's other questions. Which, more questions is like more pressure? There's actually less pressure. You can get more. You can get 30 wrong. And still pass. But then you're basically marking 3-day situation. How many questions did you get? Oh, the max 3. Oh, that's what you said we had to do for our early test. I said that's true. Yeah, for you're right, for PowerPoint. But that might not. If you do early, I think you have to do all of them. Which is a little. But if you have to do all of them, you just know all of them. Right. Yeah. It's almost easier than not knowing which ones you're gonna get.
Like we've had people, because you just like write down like, okay, we got to do practice. Oh, it's that here, that's what
Yeah. What I'm a little worried about is I'm gonna have 6 airframe questions. And you gotta pass at 70%. So I gotta get 5 out of 6. And if I miss one, I fail my whole airframe. Well, that's right. If I miss 2, sorry. If I miss 2, that's a 66, and it will be failed like here.
when you're in the airline and this happens,
So it's like, Art, can I like a 92?
which I guess is kind of a blessing in disguise on those airplanes. Because I got a 73 on my test. Skin in my teeth, but now I know, okay, I'm gonna
Those
get
are the orals.
1 tacked off, like 1 out of the list.
Sure. Just normal.
But just no more.
And that way you can miss a lot of them and still pass. 70% times, let's say 30, that's, you can get like 9 wrong.
Right.
But aim high, aim high. Don't plan on getting 9 wrong.
Oral and
That's
practice.
actually
Yeah,
really nice.
but like mentally tracking through, okay, this, me reading through it.
Were they a lot of concept questions?
Yeah. But like, if you know, not just the right answers, but if you know the concepts behind the right answers for president.
That's a basic one. And
Here. If you just know the right
Center
answers
match.
and you do not get the
Center
concept,
match.
you're smoked.
Yeah.
You gotta know the
Like,
concept.
here's my
When you
issue,
throw.
is like I get the concept, and then there's some good prepper questions that like throw
Actually,
you off.
oh, yeah.
Prepper.
Yep.
Wait,
Oh, dude.
apparently don't, but.
Just now,
Yeah.
good question.
Shoot.
It was good. The question was,
It's not bad.
you're fabricating a piece of
Have you
for T3 alkyl aluminum. You're fabricating.
satiation?
Can you have a minimum
Satiation.
amount of scratches, kinks, tool marks, etc. from that fabrication? Or can you have none of those? So a minimum amount of those
The
or
buzz
none?
for death has been temporarily satisfied. Intrusive thought.
Intrusive thoughts, no. You'll have them at a minimum, and I overthought it, and I said no. But the answer is minimum. Because of course you're gonna have those. That's why
there's
you-
one prepper question that says, it must be kept in there.
Correct. And so it had,
Yeah.
I think it may have, in the prepper question, I'll look, does it have those two, none or minimum, or is it just the minimum? In my mind, I was like, oh shoot, they added one that it looks just like it, so now which one is it?
I think there was another, I don't know for sure, but I just know the right answer was the minimum.
Yep. So,
That's like, yeah.
and then Zachary actually called me because he had a question on his. It was annealing. And he knows annealing, right? We all know what annealing is, but on the test, it's does annealing increase tensile strength, decrease tensile strength, or does it relieve stresses internally?
Which is,
And Zachary's like, well, obviously, it's relieve internal stresses. And he went, does it increase tensile stress? And he changed his answer, and he got it wrong.
Yeah.
So he told me about that, and I had the same question. And I was like, Zachary! And I said, increase tensile strength. Wait, no.
it's like one of those bad dreams you wake up, you're like, can't stop, you're pressing the wrong answer.
Dude, and then even more, just hilarious, there was an airframe basically it's two tests.
Oh.
It's basically two separate tests combined at one time. So they'd be like, all right, Shane, let's sit down and do our oral exam. Cool. All right, let's do general first. Cool. You got 14 oral questions. Based on the categories you got barometer there. Great. Here we go. 14 questions. Bada bing, bada bing. And then they'll do airframe oral. So Ryan thinks what it is. I think he's right. I'll have 14 general oral questions. So I got 80 in my and now I'm gonna have 6 oral questions for my airframe. Which is a little concerning because if I get too long, I'm done on my airframe oral. I'll be at 66. I only get one wrong on airframe oral.
Yeah.
I wish I'd gotten a lower score. I had more questions.
Yeah.
So,
So, if you fail your oral, you just go off your practicals and try to pass practical.
I assume so.
So you have to probably retake it.
You gotta retake the oral.
Retake the oral, but then make one more year, let's not waste a day.
Oh, yeah.
And knock out
Yeah.
practical.
Yeah, I wish I could have more airframe oral questions. But you can't add, you can't ask for more.
Well, we kind of
One
punished you
more.
for doing good.
Wait a minute. If I fail one, if you fail one, I think you get an additional oral question?
Yeah, I think that's how it works. No, oh, that makes sense.
So if
Oh,
I
that's
do
right,
fail
because
one,
if
I'll
you
get
fail
an
one,
additional.
you'll just get more.
Which means it'll be out of 7, which would be better. But
I
you
don't
don't
think
have to worry about it.
it's not just 6 people. I think it's just like you keep adding.
So if I get 6, 7,
That's hilarious.
if I get
Thank you, Miss Barb.
6 out of 8. So, but, do they add questions or is it always?
I think they do add questions. Now I'm trying to think. I'm pretty sure that's what they said. It said when you get them wrong, they add questions.
Which, in a sense, is a little harder, but also in a sense, it makes it easier because then you can get more wrong for the proportional number of
But yeah,
questions.
because it's not. If you'd ace your thing, there would be people who would probably
Miss a question and
fail.
then fail.
Yeah, which
It doesn't make any
I don't
sense.
think it's great.
Like having 100 questions in airframe written, it feels like more pressure, but it's actually like liberating because you're like, oh,
Yeah, I don't think if
I
you're
could get
worried
30 questions wrong and still pass. And so it's like, okay, all right, like we're gonna pass, we're gonna pass. But like I don't want to get 70. Anyway, I'm getting my codes here, and I know exactly which ones I got wrong. I got this plain.
Oh,
which
it's so
one- which one
stupid.
were- I had a question. It was what type of machine sewn seams are allowed for fabric covered aircraft? The options were plain lap. I wrote plain lap, French bell, and blanket seam.
There's no not folded bro?
No,
What?
there wasn't the triple answer like I was ready. Single, double, or single, double, and French bell, or plain, double, and French, whatever it was.
Plain folded bell, French bell.
Plain folded bell. Yeah. So it was plain lap, French bell, and like blanket seam or blanket wrap. No, it was blanket seam. I'm not ready for this.
Wait, there's 3 options?
That was it. There was
Like
no single, double, French bell, a thing that our company, French's Mustard, and the nation of France have in common, is repulsed yellow. Meaning cowardly. Calling someone yellow means like you're a coward. And everyone was like, whoa, you guys just went there. Anyway.
Questions for
No. It was something like, which type of machine sewn seam is common for fabric aircraft? Options were plain lapped, French fell, and like blanket seam. And I was like, well, the word seam is with blanket, machines, I'm just question French.
Mr. Judd. Should have been an option.
And what is that, machine sewn?
We'll take a look at that from getting my house.
Is it really? But that wasn't another thing. It was only blanket. Blanket
So,
seam.
oxygen servicing,
I
actually,
said plain lapped. I was like, the simplest one that would make sense, is machine sewn.
I'll gotta go still figure out how to do
Blanket
things
seam.
inside off.
A blanket was seam or blanket lap or no, blanket wrap. I think it was blanket seam.
You're welcome.
I don't know. Well, I just went, something was plain,
Hey
like,
David, you
they
wanna
could
know
find
the
machine
first
soap, plain lap.
fruit snack?
I think it was wrong. It was wrong. I just know the answer.
Catholic. So how much of this was straight prep wear and how much of it was just like?
75% straight-ish, like mostly straight prep wear. Like if you know it really, really well, you'll do fine.
My wife might be a little.
But you gotta know the concepts behind the right answer, not just the right answer. Because they'll flip it, they'll change the order, they'll change the wording. But if you know the prep wear concept behind the right answer, you'll be fine. And then the remaining 25%, 25 question, it was some logic, a couple of concepts we covered in class only, like big picture concepts, but applied to real things.
Tell you what.
Like, for example, let me think, well, I've told you, there was a question, the prepware question answer is that a minimum amount of tool marks, kinks, and scratches are allowed, a minimum amount.
Yep.
When you're fabricating 2024 T3 alpha aluminum. On the test, it was, Janice, on the test, it was, you can have none of those, you can have a minimum number of those, or something else or else. And I was like, is it none or is it minimum?
Right.
You're on my list
And
for
so I was
songs.
like,
Oh, no, I,
You got it? Good.
thank you, appreciate it. None, but real world, there's gonna be a minimum amount. Like, I'm gonna scratch it, I'm gonna have a tool mark, and that's why you do corrosion treating, and you do this, and you do, etch and elenine, and you paint it, and you just burnish stuff,
Yeah.
And I was like, oh, it might be done. So I said none. That's wrong.
You let them talk you out of the right answer.
Perfection? When I do this for Jesus, it'll be none. Because sometimes the answers are no. But if you do have to do a splice, then do it like this. But don't, you are not allowed to do it. But when you do it, make sure you do it.
Don't play in the highway. But if you
So-
do, you're supported.
Exactly. So there was that kind of
Respond
question
to
where
that,
like
but
it
not
took what I was really comfortable with on prepware. They're just like, grenade.
So that's kind of.
if you got stuck in the overthink, it didn't do you well.
Correct. And so I did not go back and change any answers. I did bookmark the ones I wasn't sure about. And so I went back to those like, I don't know, 10 or 12. And like, is that the best I can do? Is that the best answer? Yes, good one. Is that, like one more time, did I learn anything else over the course of the exam that can help me? No.
Yeah,
So
bunch
you
of
got,
communication stuff.
thankfully, I didn't. I got maybe 3 or 4.
Cause that's
I
the
was
one I need to go
terrible
back
on
over.
prepware. All the ones I got wrong, most of them, were all like, what type of antenna is this?
Yeah.
I don't know.
Did you get?
Lightning
Did they
detector.
not put that on there?
I had one ComNav instrument question, and it was the flying V, what I call it. It's like, which one's a VOR? And it was like, the flying V, shark fin, under shark fin, and then a glide slope. Yeah. And I was like,
I
Flying
can't say the words out of my mouth
understand why it is. Not just what it is, but why is that? So I literally was like, okay, that looks like a shark fin. So a shark fin is radar.
It'd be really helpful if
Shark.
if they showed you where it
Radar. I'm like, I got nothing else.
they showed you where it was on the airplane.
I know. Also, sometimes it looks like it's on the top of the fuselage, but it's not. Like they'll have it like this.
Are you serious?
Yes, so it's actually like
Get
that.
out of here.
So I'm like,
trying to bank. What is that?
anyway, so very little. I mean, a little
I
bit
remember
like.
there's the one that looks like a surfboard.
Yes.
And I was like, what is this?
Wait. Yesterday, I worked on this. That is a, don't tell me, that it collects things. I don't know, that's hard.
Yeah, I think it's a marker beacon.
Someone that looks like a surf. Then there's a lightning detector that looks like a blob.
Yeah.
Yep.
And then there's the box. This is a box.
Box is altitude,
Yeah.
encoder.
Decoder, yeah.
So I was like, so then like mine and mine was just like, okay, it's a box. I don't know what's in the box, but like the ATC knows what's in the box. So that's my altitude.
All I know is I can't go in the box.
Like they know, even if my altitude, if my altimeter breaks, they can tell me what my altitude is. Because they have access to my box. They just kind of, they're ready for my box.
Weird.
So
Wait, when you found out that the shark is the radar is for the reason because sharks are in the ocean, and in the ocean there are submarines, and submarines use radar. Okay, you gotta relate it to the
Okay.
sonar.
But like, you really.
No, it's the same
biology. But like, yeah, so all like keep it really brief. Otherwise, you'll be like Michael Scott, where he has his like Rolodex, and he gives Dwight his Rolodex. He has like different codes, and Michael goes, and then so Dwight is on the call, and he's like, hey, any updates on your homosexual son? And the guy's just like, and Michael goes,
Yeah,
someone's
like,
like, it's colored
puts a
green.
little dot in there.
Like,
Like,
go ahead and shut up about it.
Ruined my life.
No!
Super
It's like that
helpful.
video where the
Alright, one more code here.
with the
Trying to write things
where the
down.
dad runs over the street video
Hydraulic
games.
systems.
Have you seen that one?
Oh,
It's like,
yeah.
no! It's like,
Trying to think of
it's
what
so
question
funny.
was.
Oh boy, it's a complete meltdown.
Yeah, I'm trying to think of the
Yeah,
one
that's
I marked.
I mean, the lawnmower is a good one, but I think I probably like douse it with fuel.
Why did you do this?
Just hold like a lighter
Dude, Davey got a deep.
when you need to wake up.
And it wasn't just like
I am never gonna
the function of the degree.
The problem is you ruined the games already.
On
so
February,
it's already,
it's like,
oh,
oh,
so
it,
so if you don't ruin them quite as
pressure,
smaller, you have the
increases
opportunity.
volume.
He's like
His
revving
question
in.
was, alright, so well, if that's the case,
I'm
can
surprised
the
he didn't like
actuator
roll so
fully
long.
extend or
Yeah,
only
I
partially?
was like, take me with you.
And so he was just like,
I will never.
uh,
Oh. It's like the insurance. So
What?
so like
I think would more all
At my parents' house in the
why
basement,
we
we got like a
change the
game
pressure.
family room area thing. We've
So
got like
is
a
that-
whole like
so in the moment, it's just
PlayStation
kinda
2,
like
so like we have
really,
PlayStation
yeah,
1,
slap in the
PlayStation 2
face,
games,
I
and
know
then
the prep
we're
player.
playing.
I know the
Put them all
concept.
down
but
there,
like-
got like our two TVs, like
See,
yeah,
I'm actually where I know
it
the
feels like
concept,
we're walking
I
back
know
in
for
time.
sure
That's
the prep player, but I
awesome.
haven't
It was
just, like,
so much fun.
for
Hey, good morning.
Yeah, when's your?
My brother Gabe and I, a couple
So-
weeks, yeah, last week.
Oh, we're getting part two.
We got all set up,
Dude,
everything put in there, like we got our Game Boy
starting.
and things.
That's
We
It's
walked
like
down and
there's some
we
things
turned
that
it on, the
I
whole thing comes in, and we're like,
go
oh my
back
goodness,
through
Yep.
this is awesome.
hit.
Let's start recording,
Mainly I'm thinking
and then we started putting in some of the old games we used to
and
play.
just
I said,
kind
well,
of
my brother Jacob.
So here's what I did. I don't know
And
how
he-
you
he's
did
like-
it.
He's like,
So
dude, I almost
starting
cried.
about 2 weeks
Like,
ago,
I wanna go
I started
back.
like.
Who's taller than me? Can you grab that? Case did that probably for you.
I started making a separate quiz list of the ones that were
Perfect, thank you.
So now I've got,
All the people.
I combined some of them like weighted water, open.
Yeah.
Your
I've got
signature's
kind of
still on
all the
there.
ones that I missed.
On the,
Through those.
on the white, remember when you
So
drew?
starting on like.
Oh, is it really? Did you see it?
Anvil time.
It's not that visible. Every time I see that, I'm like, that's funny.
And
What else I don't see it?
hard until last night.
Right here.
Like at 9 o'clock. I went to bed, so I woke up, and I didn't enjoy prep.
Maybe in time.
Last night.
Yeah.
Keep
So
shining
that's-
light
I
on
just
it.
knew, like,
I'm gonna stress.
What happened?
I'm gonna think I don't know something.
I'll come back here like
I might actually know it.
10 years later.
Or I'm gonna try to learn something that I serious? You did like
They have
the
the wrong
inspection?
answer.
Did you do the whole inspection there too?
Yes, yeah.
You just did the
yeah,
med labs.
but it looked like using like the
I did the
wrong
Moodle
spacing or
labs.
something. Oh, different.
Dude, there's
Okay.
33 questions on this
Just
Moodle
like as
lab.
soon as you're using
Insane.
2.5 diameter
Yes.
prep wire,
Yes.
it's
What
like,
is
what
less?
is
I
this?
backed up the wires, I need to do the
Minimum
magneto.
straight.
And, well, for that one,
Sam.
I've done all my calculations.
Oh, that's why.
Close to that one.
It was the closest, it was like 13 sixteenths instead of 7 eighths.
Yes.
The next closest was like
I wonder when that lab is, you know when that lab is
on
for
right,
right,
but actually, oh, they use 2.5D.
Okay.
whatever.
I'll just deal with that
Hey,
later.
we're doing culvers?
I think that's the one that we gotta
Yeah.
do, or
We're
something.
doing since it's.
I need a reinstallation or something.
I might
Yeah.
skip out.
Are they,
Prep wire.
are they giving you?
When's your test schedule?
They giving you a day?
Monday.
Monday. There's a lot on stuff Monday.
Me, Joe, and Cheddar are in the same room at the same time. Me and Joe make a bet. Whoever scores high.
Extra time, I mean like normal chapel. Well, Monday was
I'm
a
telling
Friday.
you, keep
You gotta
getting.
extra 10 minutes.
I guarantee you, every time.
Sometimes.
When?
At
Yeah.
least, it's not Thursday. So if I could, it's like,
Oh,
pop
I
the
don't
ball.
know,
Cause it's,
I don't know.
if it's Case, he's definitely gonna pick. So, it's his class, that might be. But to me, it's not worth it to get a.
So, yeah, so if
The amount of
you
time
wanna
spent
make
getting
sure
from
it's
a
ready,
90
not a
to like
10:45.
90. It's not worth it. I don't know. Ask his agent.
Yeah.
Yeah. Just run through prepper once.
I'm gonna put my,
Yeah, be ready to do it. Like do it maybe like if I'm really confident about something. Concepts are expensive.
Yeah.
You're on
So
Monday,
I-
since
yeah,
they're two,
Monday.
it's fly.
I'm on Monday, Sam's on
you
Monday.
know, but I'm gonna do
I
it.
think it's today at some point.
Where do we get out?
Yeah. So
But it'd be really, what they stack, yeah. And it's kind of nice to do it right after we get really.
Yeah.
And we'll be at 8:30, so it's like right in the morning, I can take a nap down.
My food is just like.
So I've been doing, I pull up on my.
Hey, but listen, don't,
the
Yeah.
website,
just
and
Yeah.
I do,
just work at it.
I mean, I'm
I
not
wrote
like
down all the
stressed
different
about
sections.
passing.
I've been going through like 100
I
questions
just
at a
want
time.
Okay.
And so I'll do that before I go to bed.
Yeah.
Go through 100
So,
of them, like, and I
on that,
select it, so it's like,
um,
show me the
I'm
answer,
six
read the question,
airframe wall
answer, question, answer. I
Not
don't
all 14
mentally understand the logic.
And
how
you
it
need
got
an
to
answer?
I read
So
the bottom,
I'm gonna.
but that's how I'll do it. And then I come in here, well, I listen to it,
Sorry,
or
if I
like
get
on
two
YouTube
wrong, I'm in
on
trouble.
the way in, 'cause I got an hour drive.
I'll be 66%.
So I just
Yeah.
But
run
also
through it,
that,
that section, and then when I get here, I go through some of the computers. So technically, I try to go through each section 2 or 3 times, and then I decide, oh my goodness, go to the next section.
Yeah.
I'm hoping it all sticks.
Right, right, that's the
Let's
thing.
say-
I heard that like if you get some, do something, and you get learning something, if you take stuff away for a little bit and then come back and spend, it's like that much more cemented.
Okay, so that would increase your chance.
So I'll get all the, I'll go through prepper, and once I get wrong, I'll leave wrong.
Cause I'm
Go
going
over
over
and
my
keep going down,
six.
and then once I do that,
If they
then
don't
I'll know the right answer, I'll
I
get
get
two
two
wrong
wrong.
question, but once I
Airframe
frame, I'll go
wall.
back,
Yeah.
and start at the top, and fix all the wrong ones.
Yeah.
And then it cements my brain, I remember those way better than I remember the ones I got right.
I had.
Sometimes there's like a
lunch,
gray area.
and I had
You
eight
think
copies
it's
of
the right
wares.
answer, you got it right.
It's
Yeah.
like, what
Because
are
now,
the-
I hope you remember that.
Of these three, what's the most likely,
It's like that sad emotion.
situation for flush time? It was over 65% humidity,
Yeah.
under 65% humidity,
Oh my goodness.
and something else.
Or how,
that
how
had
much
nothing
your
to do
retention
with,
might be
no,
every
it
time
has
you
to be
select the
humidity.
wrong
Maybe
answer, you
like,
like shock.
erosion, something around it, so I'm like, well, it's humidity related, so probably over 65%
Safety,
humidity.
guys,
Anyway,
safety.
That's good. That was
This is all for safety.
It caught me a little unaware, like, oh,
Every time you get it
yes,
right,
flushing,
you get like,
yes, gotcha. So,
Cha-ching.
like,
So this is like some
look
like science
back.
experiment, like they like,
yeah.
for like apes and
well
mouse
prepared.
and mice, they like,
but,
you get stabbed if you,
and obviously each
if
test
you
is
do,
randomly
you
generated.
get a prize.
Right.
So like, if I had gotten more math, more setback,
That was- that was
I would
Did
have
they do
read
that?
more.
Did, wait, I feel like they did something with chickens or something like that, or doves or birds or something like that. They would have, they would put birds in bombs, you know what I'm saying?
Yeah.
And then they would train them. They would train them so that when they see it,
I think it's
they peck on the target because they're trained to peck on the target. And then
It
it's
was,
guides.
it was my first FA.
That's hilarious.
And there's
Yeah,
hard to know
just
what to
pigeons,
expect.
homing.
In general was, it was so broad.
You probably were pretty
There's
accurate.
so much going on.
Who's the
I don't
next
know.
I mean, I don't know.
Is that?
Yeah.
And then they had,
sensing different like chemicals or something like that. And they would react a certain way because they would train the chemicals and you train different squads of bees for different things. I think that was. It's been like it's kind of crazy. They would react a certain way.
And then they, and so the first 10, and then it was like category, like, here's 8 hydrology questions, here's 6 electrical questions, here's
I really don't want to start this 33.
non-metallic questions. And it was just like category, 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 category. And it was just kind of plug and play. It was kind of nice to be like, all right, I'm in hydraulics right now. Hydraulics, okay.
Hungry.
6 to 8 questions.
Do we have Devos today?
Done, and there were no more.
do.
Now it's electrical. And now it's time for painting. Oh, well.
You had a picture of him.
Oh, is it part 2 of his?
It's got that one
Yeah,
question.
him and his wife, he has a picture up there.
Nice.
That was it. I was surprised.
You're probably right.
So it was like the stuff I was most worried about.
Yeah,
was, like,
I didn't do
really
great on
for,
my general.
Didn't have a ton.
What'd you
There
get?
were maybe a total
I got
like,
like 78
I got
or 76.
12 electrical.
I didn't realize software was a thing.
So proportionally
Like, I didn't
speaking,
study at all on it.
They,
Wow,
I
that's
went in
like
like, we have
years
a
ago.
ton of
Well, I
electrical, and
remember
it
on
was
my
like,
brain.
yeah, I had about
And,
12
yeah,
electrical.
That's still super impressive
And it
because
was like,
a lot of prep
I had
work is
0
just
wasted water.
kind of
And
they
I
30 for a
had
loop sometimes.
a couple
It's like
of
this isn't